between his own company and consumer electronics giant Mitsushita, communications giant AT&T, and the world's largest vendor of entertainment software, Time Warner. The result is a new standard for interactive multimedia.
We really look forward to the final emergence of what I've talked about for a long time, which is the new Hollywood, the merging of Silicon Valley and traditional Hollywood, which you see represented on stage here today.
With our filmmakers and television producers, and in fact people and talent in the music business, we find it possible for us to tell our stories, to develop our drama, to develop our characters, because of the graphics power. It's not just the numbers, and it's not just all of these boxes and what they contain. It really represents a very meaningful watershed for an entire software industry, and that is the software industry in Hollywood.
When we saw potential of technology at 3DO, we are very encouraged to make a significant investment in 3DO.
3DO can process images 50 times faster than a PC or a video game console, thanks to custom animation processors which run in parallel. The system can process up to 64 million pixels per second. In addition to the graphics chips, the 3DO system also includes a custom digital processor for audio, a specialized video processor, and a 32-bit RISC processor for program control. The system also uses a double-speed CD-ROM drive for fast access. The net result is a lot of computing power that gives you smoother images, cleaner scaling, and texture mapping. 3DO calls it cinematic software.
You'll see a new kind of interactivity. For example, there'll be movies that are done as a linear stream just like they are now. It's a storyline that has a set beginning and a set end. But now you'll begin to see what are called interactive pictures. These are stories where the storyline can change, or the perspective on how you view that particular story can change. And it'll be a new form of media, just like in the beginning of motion picture, all they were doing was filming a stage play. It wasn't until later they began to understand how to use the medium of film. This is a new medium, and it'll take a couple of years before people really understand how to use a new medium like this.
More than 80 software companies have already agreed to publish CD programs that take advantage of the new technology. 3DO plans to charge them a royalty of $3 per disc. The system itself, which consists of the chipset plus the cinematic software tools, is being licensed at no cost to any hardware manufacturer. The first 3DO platform is due out this fall from Panasonic. The price is expected to be around $700.
It's a product that's going to be in the main room of the house, where in the past you had a home office and then you had the other games in the children's room. This will move into the family room, and everybody will participate.
Though most of the talk about 3DO has been in the context of a game platform, Panasonic believes the 3DO technology will also find its way into education and business.
Eventually, definitely with the educational capabilities and with the fine quality of the performance, with the graphics, the power in the unit, and the fast interactive, it's a natural for school systems or teaching or educational. Training, even business training, visualizes programs that you can have sales training on a machine, hands-on.
Real. You know, 6 months ago we had the promise, and now we have the reality.
The circuit board is the heart of a 3DO interactive compact disc media player. Panasonic will release the first 3DO player in October under the name Real. Wall Street thinks 3DO is real as well. The company's initial stock offering last month made headlines and raised nearly $50 million.
The positive response to 3DO indicates that there's a lot of confidence that investors in Wall Street have about multimedia generally and about 3DO specifically.
To get specific about 3DO, the device uses the huge data storage capacity of the compact disc for video games, educational programming, and within a few years, full-length movies. The unit is also designed to serve as the control center for video on demand and other information superhighway functions. It'll arrive in electronic stores in October, carrying a list price of about $700. $700, but although the question of which interactive format will catch on is still open, 3DO chief Trip Hawkins has little doubt that interactivity is the future mainstream of the consumer electronics business.
We like to interact. That's part of our nature as mammals, is to play and to interact, and it's one of the ways that we are creative. And you can't get that just from pushing buttons on your remote control for your TV. There's got to be something more.
And the industry hopes much more. Dennis Michael, CNN Entertainment News, Chicago.
Hello, hello. There we go. Get the mic working. All right. As I was saying, gonna work on finishing up some FreeBSD porting of mergerfs, and then maybe look at some 3DO debugging. There was a announcement today that that the gentleman who does the Saturn FPGA core for the Mister is been working in the background on a 3DO core for the Mister. It's pretty early, and let's see, where was it? Here we go. It's pretty early. Doesn't actually do any of the distortions of necessary by the cell engines to do anything but kind of standard 2D rectangular stuff, and clearly there's some performance issues. I kind of wonder whether or not the VRAM is part of the problem here, but I've never spoken with the individual who's working on this. Hopefully, well, I take that back. I think I might have spoken with them once some time ago, but very briefly about the 3DO technologies. And one thing that, a few things that stuck out to me while watching this video is, if you watch, generally speaking, the full motion video seems to run full speed. Now on the 3DO, even though there's a number of full motion video titles for the platform, of course, that was popular at the time, the machine actually has no hardware acceleration for video. So all the videos are software decoded on the GPU, or on the CPU. The GPU has typically is not used at all. The original SynPack decoder is all in ARM assembly, and in fact writes straight to the frame buffer, which is why you'll see tearing in certain titles, because the video writes to the frame buffer as fast as it can, or the codec is decoding as fast as it can, and there's no VSync because it's writing straight to the buffer, and you need to do double buffering to make it so that there's no tearing the way that the system's designed. You can't like race the beam or anything like that. So if you look at a game such as Escape from Monster Manor, they actually don't have tearing, and the reason is because the author, and he told me this directly. We do have the source code for that now, but he told me that he realized that all these titles had these tearing in it, and so he renders to a different portion of the memory buffer or the VRAM, and then flips that every V blank. But anyway, what you notice in this video is that the full motion video, generally speaking, seems to be running full speed. And again, that's likely writing straight to the VRAM. But that's not the part of the system that Fixel, myself, and others have questioned whether or not the MiSTer can handle. That part is actually, so this VRAM is dual ported, which is one slight complication. But the bigger complication is that if you're into hardware, in recent years, there's been discussion of trying to add logic to RAM, so that, for instance, maybe you could, imagine if you added a little bit of arithmetic to every cell. Now, will this scale particularly well in terms of like gigs and gigs of RAM? Probably not, but you could imagine a RAM setup where you have a certain amount of parallel logic across all the cells, so that you could do something like multiplication or addition across all those cells in parallel. And that is, it's not exactly what's going on with the 3DO's VRAM chip, but it does have an internal mechanism. There's like a serial port that's connected to the chip where you can instruct it to do certain things that are hardware accelerated. And some of those things are copying of 2K blocks of data around within the memory. And then another is setting of data. So you can set a word at a time across a block of memory. And then you can set bit mask. That you're also allowed to do bit masks. So there's like a value and a mask. And so you can say, based on this bit mask, write this data. So you could imagine if you had an all-white scene or something, you could set the bit mask to A5, 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 A5 or something, and then set it to black, and that would just set individual bits within all those, and then leave the other bits the way they were. So you could actually do these like patterns. Now, how useful is that in practice? Not terribly, but in any case, it is something that can be done and something that is occasionally done. So those features would have to be supported. The biggest feature is really the setting of values and the cloning of data between these blocks. That's used very regularly in titles. And the thing is that it is extremely bursty and works by setting up the instruction, and then effectively every couple cycles, in less than, I think it's less than half. It's been a long time since I looked at the data sheet, but in less than half the time that it would take to do normally, it is able to either copy data or write data. And that level of performance is what is raised concerns that the external SRAM, like we get 128 megs of RAM on a stick that you plug into the MiSTer, that you wouldn't be able to get the throughput that you need to emulate this. And so I wonder, when you get to parts of the video where there's actual gameplay, and it's using the cell engine, you'll notice it's pretty jerky and latent. And I wonder if part of that latency is a result of the increased, like, if the VRAM is not effectively cycle accurate, that it's taking longer than expected, then every frame that is using that to blank the screen, every frame or every field, if the game is not like fully redrawing the screen every time, then that could be part of the problem, or why it's slower. Now, this is just speculation, but it's certainly a possibility. And then the other thing that I noticed was here. So like this intro is clearly very is much slower than it should be, and it almost looks about half rate, which so the Super Street Fighter 2 Turbo is the only game that I'm aware of outside of Homebrew that actually runs at 60 updates per second by treating every field of an NTSC 480i signal as an individual field. And if you look at this, this appears to be running at half rate, which if again, so that they've got to be blanking out the background. Now maybe they wouldn't need to, but in this with Ryu, they would need to be blanking the screen every time to black before drawing all those components that make him up, which are all independent. These are all different cells that are just rendered on top of each other and animated. But that blanking background, if that's actually taking longer than a field to render and it's waiting on VBlank, then that would probably explain it. Again, there's other reasons why that could be happening, but again, if the VBlank clear is taking longer because the speed of Mr. is simply can't keep up, the 3DO is runs a high level operating system, and so it's plausible that things would still work, but would be just slower. But the other thing that's interesting here, besides there's like some artifacting and stuff going on, is when we get to the character selection screen. So we fast forward this a little bit. Oh, that's not it. That's still, here we go. Oop. Come on, if I can get it. There we go. So typically, this select game speed should be as it appears, right? So there's three cells here. There's this checkerboard pattern. There's this white block, and then the select game speed. Like this whole thing, the fast, slow, 1, 2, 3. All of that is a single image, and it draws the background first. It draws, I think, then the mesh, then the square box, the selection box, then the select game speed, then maybe push start, and then the rest of this. And clearly this is off by whatever this is, probably like 10, 12 pixels or something. And the interesting thing is not that there's this rendering bug in his FPGA core. What's interesting is this is in my emulator Opera, and it's been there for quite a while. And I just haven't gotten around to really investigating what this bug is. I suspect is something like really subtle that is probably part of the rendering pipeline, but not hit very often, because otherwise, if it was like corrupted memory, or if it was something to do with just very explicit rendering routines, then the emulator would fail all the time, and clearly it doesn't. So this is the only place where this is occurring. So it's either like these are placed in a relative position or something, and the rendering pipeline is not storing the right state or whatnot. But it's interesting to see that he has this issue. So it makes me wonder whether or not he was leveraging Opera source code as inspiration to his work. Hopefully at some point I'll get a chance to talk to him about it, but it's exciting to see, and it sounds like he's probably the right person to do it. I don't actually have a Mr. Yet anyway, and so I don't pay that much attention to all the developers who write cores, but I guess this guy is well known in the space, particularly for his Saturn work. And since the Saturn works on quads in a different way than the 3DO, but similar enough, excuse me, in some ways it makes sense that he would perhaps poke at the 3DO despite them otherwise being quite designed in quite different ways. So anyway, let's finish up this. So I think this is the last thing I need to do. Is I've got this preload library that I include with mergerfs that interacts with mergerfs to allow you to get effectively native speeds by interrupting open calls and then looking up what the underlying file is according to what mergerfs would do, and then taking that information, bypassing mergerfs entirely. Now it's kind of hacky, but it works, and for certain workloads, this can massively improve throughput because you're going straight to the original underlying device. There are other ways to do this. One would be using ptrace. The problem with ptrace is that it has to run externally and then force your application to allocate the necessary resources to do what it is that I need to do to take advantage of it. And I simply haven't gotten around to building that out, in part because there is a pass-through feature in Linux now that in theory could make this irrelevant, but we have not gotten to a point where I can really practically implement it due to some limitations in the implementation. But in any case, unsurprisingly, FreeBSD is a BSD, and the way they define things, I learned, is different. So if you define that this is a GNU source, they actually interpret, I don't know if it's the GNU source or the POSIX source, but in any case, they disable certain features that maybe they shouldn't. Like arguably it's a bug. If they're going to understand these macros, then you could argue that it's kind of a bug. But if you define these, OPath disappears, is not defined. It's only if it's defined as BSD oriented code does O underscore path get defined. But if you're doing a POSIX source, you should have OPath. So I think it might be the GNU source that kills that. Actually, let me maybe put this here like that. And then FreeBSD doesn't have temp file, so that breaks if since I have to explicitly grab or look for temp file. Right, temp file, right? Yeah. Make preload. Okay, so that works. I'm gonna submit this. Let's see, git rebase master. I have a FreeBSD 13 dot whatever virtual machine here, and I've been using that as a test bed. If we go git fetch, git reset. Right, make gmake clean, gmake preload. Oh, that's interesting. Let's see, 2 and 1. Yep. Oh, brain fart. ambiguous. Whatever. Okay, that's something different, but there are these errors. Error use of if register. Huh. Okay, let me, because I know I got this working before, so maybe it's that. Let's do fetch and reset and oh no, gmake preload. Okay, that worked. Oh. Dynamically linked LDD preload or NM preload. Okay. This, I imagine, will work. Strace on here. Package install strace. Strace has been found. No package. Oh, interesting. Well, whatever. I'm sure it works. All right. So in that case, let's look at this. Git show. Okay, so I need to include some of these details in. Oh, actually, that might be related. Okay, let's. Because the person who patched this for FreeBSD originally did this up here and commented out schedule get affinity, but as I recall, schedule get affinity. Oh, interesting. I thought I saw FreeBSD had this. Man pthread set affinity np. Okay, this exists apparently. Pthread np.h. Does it refer to schedule get affinity? No, it does not. Schedule files this in CPU HPP. Let's look at that. Fuse lib CPU. Right. So these. Let's man sketch.h. Nope. Man pthread.h. No. Okay. Let's check FreeBSD. Your wishes. How you doing? FreeBSD man schedule get affinity. Yeah, so I mean, there's this man page. Here's some Russian man page, unix.com FreeBSD man page. Oh, oh, that's interesting. You have to define GNU source. Well, let's do a quick search for this. Grep bar. Glad to hear. Doing good, thanks. Let's see. We want to search for schedule set affinity and user include. All right, so it's there. Sked.h. Sketch. And this, okay, if it's BSD visible, which, I thought if BSD visible was defined, that meant the GNU source is not defined. Is this just wrong? Oh, this does say Linux Programmer's Manual, and yet this says FreeBSD. Curious. Is there a... Okay, there's man.freebsd. I didn't notice that before. Okay, let's look up get affinity. Oh, 4. Not special files. All sections. Still no. That's interesting. Did I spell it wrong? Let's just look up sketch. Huh. Oh, that's 11.4. So that's old. Let's try 14.2. Well, we're on 13.4, I think. So let's try this guy. No, let's get affinity. Huh. What the hell? Let's see. Get CPU. They're right here. So why would they not be in the man page? Okay, keyword search. Nope. Get CPU. Nope. Schedule underscore. Nope. Just schedule. No. That's a shell command. Curious. Let's do a whole BSD search. Sketch. Get affinity. There's set affinity. What the hell? Oh, wait a minute. Why does FreeBSD have CentOS man pages? What are you doing, guys? What the fuck is going on? Problem with get affinity. Okay, that might be interesting. More compatibility with Linux. Okay, that's good. glibc, blah blah blah. Fix error no meh. I mean, I can keep it as it is and just leave it commented out and say, like, tough shit, FreeBSD doesn't have CPU pinning. But I'd rather not if I can get this to work. Okay, let's go back here. So, first of all, I probably need to put it in cpu.cpp instead. And instead of this, we should probably do, first of all, I should probably include a license. For some reason I didn't. So we'll add that. You know, it's a preference of mine to put the license in every file because it is not super uncommon for projects to be a mixture of other projects that aren't owned by the copyright holder of the project, because you can embed, and especially copyleft licenses can be embedded and LGPL and stuff without any licensing legal concerns. So it just makes it a lot easier if you just put a header in every module what the license is. Now, if you have a lot of contributors and what have you, then of course this can get a little bit more complicated. But in my case, like 99.9% of this code is mine, so yeah, it just makes it easier. But all right, so then so if I do if define FreeBSD like this, I don't want to define, let's do undefined GNU source. Make sure that's not set. I want to make sure it is set with Linux. And then I think I need schedule no matter what. Again, it seems strange to me. I love adding the license also. It seems strange to me that FreeBSD, in the name of compatibility, would then require you to make sure that GNU source is not defined, when GNU source is often required to get those same features. Seems, and I hope there's a reason for that, but it could, I mean, in theory, could also just be something they overlooked. But set affinity NP. Okay, so they have that as well. So, but I think they include, what was it? Python pthread np.h. And both of them was schedule, I think. So, because yeah. So this requires pthread np, whereas on Linux it doesn't. Actually, let me double check this. Man pthread np. Right, so it's just in pthread, but you need GNU source. So, oh, I don't even have pthread here. But I am using it, yeah, so I should. Something else must be including it, but just to be thorough. Okay. Maybe this is good. Let's see. Clean make sure this still builds on Linux. And then I can copy that over. I don't know if people notice I've got a little kitty cam here on the do I not have the mouse set for showing up on screen capture? Let's see. What are my settings for screen capture? Oh, cursor capture. Here we go. Oops. That would help. I guess I've past few streams didn't have that. But over here I have the kitty cam. It's a stray cat that comes around all the time. Will not let us pet him. Will not let us get near him, except for like a couple feet away. And it's been months now, and he comes by almost every night now. We've been trying to like get him in the house to try to adopt him, but he very skittish, will only come in the house a little bit and then runs out immediately after eating. For some reason the past week he's been super skittish, more so than normal. So I don't know if something happened or what, but somehow he is onto our idea. Yeah, he comes into the house on occasion. For a while he would walk right up to the door when he would show up and just like sit there and stare. He doesn't meow, doesn't do anything. Just basically mute. I think he might also be hard of hearing, but he'll just like stand and sit at the door and stare. And then I would open the door and I have an old wood and like metal screened fence door. So I open up the main door and it swings inside, and then the screen door swings out. And so he would like back up and then immediately like put his head into the doorway. And if I put down food, he would walk in. And for some reason, he's just not doing that lately. My wife says it's because I trapped him one time in the house, but I the very next day after I trapped him into the house for a couple hours, he came right back in. So, I mean, I suppose that's the reason, but it wasn't an immediate response. But he just, yeah. We call him little shit because he's just a little shit. Like, he does not, again, he doesn't let us pet him. It's been months. It's been like over 6 months of us feeding him probably 4 or 5 times a week at least. He'll come by in the middle of the day. He'll come by in the morning. I'll wake up at like 5:30, 6 in the morning, and he's just sitting out there waiting to be fed. He'll come by in the middle of the afternoon sometimes. He'll come by in the evening all the time, and still just does not want to be pet. And so, just from a personality perspective, his name has been designated by my wife as little shit. And yeah, he is, because he is one. And yeah, so right before the stream, I put out some food for him, and you can see, like, he's sitting there, you know, taking a drink of water, and then often he'll go back to the welcome mat, and then just sit there for hours. Oh, he's actually let's see if I can move the camera, see where he's going. He might just be leaving. So he also likes to sit in the driveway and just watch the neighbor's yard. I think it's because there's like possums and raccoons over there, and he hears them. Yeah, he looks like he's going off for a while. He'll probably be back. He'll come back. So he'll leave sometimes and then come back within less than a half an hour, and he'll spend hours, like literally from 6-7 p.m. until 1 a.m. He'll just hang out on the porch. He'll like walk around a little bit, do some surveying, just stay on our porch. He's started to like sleep in the backyard on occasion too. He's done that like 2 or 3 times. And again, he'll just kind of survey the neighbors, the fence, as you can kind of see in the there on the side, like on the right side of that post there on the porch. So it's he's a weirdo. We also have a new cat, an orange cat, a ginger, that has come by recently. That let me just try to realign the camera, catch anyone who comes by later. We've got a younger ginger cat, probably is no more than a year and a half old, and he's super skittish. His ear's not clipped, so I think he probably hasn't been fixed. It's hard to tell because he won't let us near him, but he's a cute cat. We've got a couple probably neighbors' cats come by. It's a regular farm here. Not to mention the peacocks, and then the foxes, raccoons, possums. Surprisingly, not many dogs. 2 of our cats were strays that decided to stay. Yeah, I mean, I've had probably 24 cats over my lifetime, between basically growing up on a farm and then as an adult, I've had a couple cats. But my wife never really had pets, so she's also slightly allergic to cats, but she has come to appreciate cats, and so we're probably going to get one, but when little shit showed up, we were like, oh, we'll just adopt him. We just got to make him comfortable, and eventually he'll just want to stay inside. But then the Texas winter came, and it's like 30 degrees outside, Fahrenheit, and we figure, oh, well, he's been coming in the house. He'll eat while he's in there. He'll just want to stay because it's warm. Nope. The second he's done that last nibble of food, he just walks right out the door. And like I said, this past week, he for some reason doesn't want to even do that. So maybe the ginger cat will be our stray take-in, but and little shit will just be his outdoor brother. But we shall see. Okay, so that built. Let's push this, and then check. Go back. Git pull, and then yeah, the last stream I did, I was using I wasn't using KVM mode, which is why it took fucking forever to compile. I fixed that. So now it actually, and I gave it, what is it, and proc 2 CPUs. I probably should have given it. Well, this machine has 4 physical cores, so that's probably okay. Though maybe I should have given like 3 or 4, but I don't feel like rebooting now. Let's do gmake clean, gmake sj4, and see how this goes. There looked like there was a issue with the trim there too. Let me make sure. Yeah, so undefine that. That should be good. I wish you could just make it so the QEMU didn't grab the mouse. Is there any setting there? No. Take a second. All right. What was that? There was that other. It looked like it gave an, if not an error, something about trim, and that would be in Fuse CPP. Malloc trim. Fuse malloc trim. Fuse malloc trim. Have malloc trim and include malloc. If defined, right? So this should not be defined on FreeBSD, and so this should not be called. So there shouldn't even be a warning. I'll have to wait for this to finish. Actually, let me just look at this now. Lib fuse touch. Oh, make clean. Gmake clean. Gmake. Oop. Not that. Okay. Crap. See, I can't scroll. Gmake clean. Gmake. Unused function. Oh, that's for I should just delete that. That's for a different. So libfuse uses a very, because it was written by libfuse was written by the developer who wrote the fuse for the kernel, and he uses a very kernel oriented data structure, like a tree with a built-in where the right, because there's 2 ways to write these kind of data structures in C. One where you embed the pointer to, say, the other nodes into the data structure, usually is like a header, and then you can use like container of in the kernel, and that's how they do things, to figure out like from an internal data structure like what the container is, and then you can get the pointers to, if it's a list or a tree or something, and then or you have a tree and then you just point, you have like an opaque pointer to the object, which is less efficient, and the whole data structure has to be locked when interacting with the tree, which is really not ideal. So I started some time ago trying to create a new data structure, but that was kind of this. I mean, you still need like a tree structure, but one that maybe contained more information in it for certain to like make certain operations not need locks. But I didn't get as far as I'd liked. Okay. Am I just missing the touch cpp. Huh. I could have. I thought I saw an error. Oh well. I guess I did. Okay, maybe it was just the stuff. Basic string view. I should look at upgrading FT format. Because I don't want to upgrade one of the problems. Cell
Chelsea Shaw just followed.
Yes, thank you. Thank you for the follow. Hello, hello. How you doing this evening or whatever it is for you? Unused functions, whatever. What was I saying? Oh, yeah, I didn't want to upgrade. One of the problems I've had with mergerfs, and which is less so now, but for a long time, I am responsible for building packages for a lot of distros because distros are out, Debian or whatever. They're not going to upgrade old packages. And I had a lot of users that are on. I mean, this is server software, so you want to support older platforms. And I spent a while pushing off even moving to C++11 because what was it, Debian 6 or 7 didn't have compatibility with C++11 fully, if I remember right, the GCC version. And then eventually a few years ago, I moved to C++11. And so anything past C++11, I've largely had to use as external libraries that I just embed into the project. For a lot of my other stuff, I use C++17, and I got to double check to see what kind of my older platforms are to see whether or not I should just say screw it and move to 17 or not, just to minimize some of the dependencies on the external dependencies that I include, which are internalized, but still I have to maintain. So FMT I would still need to keep around, but like the file system library and a few other things I might be able to get rid of. Come on. Okay, while we're waiting for this, let's just rebase. And then, oh, shit, I did not, right, damn it. Okay, this is not a good representation of, so pthread, I need to keep schedule, I need, because of CPU set T, I think, right? Yeah. But then I need to do, can I maybe just get rid of this? This is one of the big problems with Unix sometimes, or C, is especially across different Unix systems or even different operating systems in general, is that the definitions of things can live in different header files. But what I tend to do, and what I do for the 3DO, is I tend to put like it leads, it has its own problems, but I find that I'd rather deal with those problems than not, which is I just put everything in their own header files. So if I have a bespoke data structure type, like in this case, there's, pthread T and CPU set T or whatever, I would have two separate header files with those definitions. And so generally you would include like the top level header that would include those as well. But in a niche situation where like in this header, I don't need the declarations of all the pthread functions. I just want the data types. And there's no way to just get those data types. Now, generally, it's not a problem, but it is convenient in certain circumstances. Am I even using it on? Okay, I am. Unordered map. Right. Let's see. Okay, so this still compiles. BBF is another one of my projects. It's a bad block finder. I really need to rewrite it. I wrote it years ago, and it's really not in a shape to be. It's publicly available, but I have never packaged it up. But what I have in it is a mode called file system thrashing, which I use for both burning in new hard drives and for testing mergerfs, because it just spawns a bunch of threads that do nothing but like grind a certain function over a file path. So like a thread will just create new files, another one will scan directories, another one will scan the directory and then delete files, another one will change mode, change owner, rename, etc. And it just grinds as fast as possible to do that on the file system. And it works pretty well for testing things or stress testing things. It could probably be more nuanced in its behavior, but it works mostly for my purposes. So I was doing some stress tests on some changes I made recently, and thankfully they passed. Best show. Okay, so that builds git push. Fine. And then check this. Git pull. No. Git rebase, or not rebase. I want to fetch master. Oh, not origin master. BSD. Okay. Git log. Make gmake. Does it work here too? Of course it does. No matching call for that guy. I wonder if I need to. I don't set GNU. No. So let's try undefine GNU source. Git push. Git pull. Should probably just install Emacs on here. Oh, interesting. So, shit. And schedule get t. Huh. We looked at the S user include schedule h. What is it doing here? 2021. Schedule if BSD visible include CPU set structure underscore CPU set define CPU set. Okay, so it's opaque. And then begin if BSD visible. So that is apparently not being set. Let's do some sleuthing. Okay. FreeBSD BSD visible. There must be something that's defined that isn't allowing it to be. What is BSD visible for? It's throughout the system header files that are located at specifically I'm looking for, okay, whatever. These are a few features that are traditional for BSD, but which are incompatible with POSIX. But I don't think this is incompatible with POSIX. Maybe I just shut it off. It's not like there's that many BSD users. If one of them really wants CPU pinning, maybe when FreeBSD is not recognized, but POSIX source is, and is actually causes the BSD functions to be hidden. So I have to manually add it to get them on BSD. Why does Linux require BSD source, but FreeBSD requires BSD visible? Is there some standard? Why is this shit so cryptic? When your code is wrong, why? Oh, then your code is wrong. Why don't you use POSIX names? Want a POSIX namespace? Then you shouldn't be defining POSIX source. Your application has no business in defining that. Because Linux or more likely glibc made a bad decision. POSIX ones are in addition. So is it POSIX C source that is the problem? Did I install Emacs on here? Yes, I did. So let's try libfuse libcpu. It's a little easier. Okay, let's try. Undefined C, or was it POSIX C source? Nope. No matching function called. That's exactly what's defined in that. All right. You know what? I don't have time for this. Let's just. This should be fine for here. And then for the implementation, we shall just hide this shit, I guess. Sure. Do I even need this? Let's try define schedule get affinity. What did the other guy do? Where was the BSD patches? Guy added a link to installation. Yeah. Oh shit, this is not where it was. Where were all the patches? FreeBSD. I don't know. I must have lost it. I wonder how many problems we could solve if C never had defines. Well, I mean, if C didn't have, I mean, the thing is, the C preprocessor is like a macro language, right? And so you kind of have to have defines. If you got rid of macros altogether in C, well, I mean, you'd have to solve these problems somehow, right? So, I mean, I don't know the specifics here in the history-wise, but my speculation would be that the C preprocessor kind of manifests itself out of the need for the headers, right? Because headers are just embedded. Like anytime you do an include, it's just embedded straight in, right? So an include is just embedding of that text at the when it runs through the C preprocessor, and then the pound define you need to do variables in the CPP language. So you'd have to solve that. According to that commit, the schedule get affinity is only in BSD 14. Oh, the one in front of me. I mean yeah, I mean that's what it suggests, but like, if you look in where the hell's the VM? If you look in here, right? So this is this is 13.4. And if you look in schedule.h, sched.h, it's right. They claim it's defined. So maybe they backported it. They ported it to FreeBSD 14 first and then backported it. But I think this is a patch though, right? So see, this is like fixing errors handling, I think, because it was already there before, because they've got the CPU set affinity thing that is must be like the BSD way of doing it, and then they added this. Is that just the headers though? Yeah, well, like we're not even getting to a link stage, right? It's the header that's causing it to blow up. But it's I think it's just something to do with what this if BSD visible, and everything I'm seeing is some different, right? If you have different things defined, then if BSD visible is not defined, and therefore this section doesn't get defined. But that's why this is weird, right? Because if the whole point of adding these functions to FreeBSD is to make it more compatible with Linux, but it's common in Linux to define, GPU source underscore GPU source, or GNU source, I mean, and that disables BSD visible, right? Like you can't have it both ways. There's got to be something I'm missing, because that doesn't square. And I tried to like unset before including it on BSD. I tried to unset it, so there must be a different Emacs libfuse libcpu. Right, I tried to if define FreeBSD undefined. I mean, I can pull this stuff out because we're on the BSD system just for testing. So these are the two defines that were mentioned, unless that systype or something defines it. Yeah, well, I mean, that's the suggestion, right? That something in sys is defining BSD visible, but other things I read said that if you define GNU source, it undefines BSD visible. Right? So if you put it into a Linux compatibility mode, effectively, it removes the Linux compatibility stuff. That's what it seems to be happening. Right? That's what this thread appears to be arguing about, where this BSD visible, and then like you shouldn't be defining this. POSIX C source is a restrictive thing. And then they're talking about there's another thread I saw where, but like, okay, so let's try this. So I've clearly undefined these. And let's just go to lib. Right, so there's got to be something else because I'm including Emacs lib CPU. Let's see. CPU.cpp. Oh, lib CPU.cpp. Right, so I'm including sketch.h, and okay, hold on. Let's be extra thorough. Let's put these here. Nope, that didn't help either. Or wait, are these different? Oh, hold on. Am I not reading? Declared. Oh, no, okay. No, this is... Now it's something else is fucked up. Cannot initialize a parameter of type PID, aka int, with an L value that is const P type, P thread. Okay, so... Let's... Lib, not libs. So probably one of these guys must be defining these. It's not cpu.h. So it's got to be something else. I mean, it could be anything, right? Like this is the pain in the ass that is C++. And I really don't want to do this, but then again, it's failing anyway, so it doesn't like... let's look at user include h.h. So, right, it's PID. Oh, is that why? Are they compatible but not compatible? Did I just miss that when I was looking at this shit? Man, sketch, get infinity. Oh no, this says it's PID as well. Oh, shit. That's why. Wait a minute. Are my types wrong or P thread type? Can you check P? Well, I think what's happening is probably related to how how Linux versus FreeBSD handle threads and processes. And I think get affinity. Where is this? Where am I using this function? Set affinity. CPU thread. Let's see. Get grep CPU set. I'm calling it in fuse loop, right? So let's look there. Yeah, it's the thread ID versus the PID ID. And let's look at fuse loop. So it's I think what's happening is that you can't you probably can't pin threads, at least with this API. You can't pin threads to CPU cores on FreeBSD with a thread ID, because a thread ID is fundamentally different than a PID in FreeBSD, but is not on Linux. So that is likely what's going on here. And where is my CPU set affinity? All right, so I'm iterating through thread IDs. And treating them as PIDs. And let's look at the man page for this. PID, where's PID? PID. So sets the CPU affinity mask of the thread whose ID is PID, whose ID is PID, to the value of the specific mask. If PID is 0, then the calling thread is used. The argument CPU set is the length in bytes of the data pointed to the mask. Normally, this argument would be specified by type of that. If the thread specified by PID is not currently running on one of the CPUs in the mask, then it is migrated. Thread ID? Thread D? No. So, is get PID, get again affinity, thread whose ID, what is it? Man get PID, right? But this gets the thread ID. And is it simply thread ID returned by this clause not the same thing as the product, right? Returned by pthread self. So this is just dumb luck, actually. I probably, when I originally wrote this, fucked up and did use the thread ID as the PID ID, and it works because I know I tested this extensively. So interesting. Can you even, I don't even know if, yeah, so it's kind of dumb luck because I think a thread ID is just, in Linux, is just the PID maybe. Let's look this up. Linux thread ID TID to pthread T. Because I don't think you can just get yourself a bunch of TIDs. Integral type. Is there a way to link the thread to map to TID? Yeah, I mean, technically that is true. Historically, prior to NPTL, pthread did not map one-to-one with TID. You would need to use pthread's library implementation details to peek at the TID. I would not recommend doing this because such code was not portable. For curiosity's sake, only with glibc, pthread is a structure thread pointer. Oh, interesting. Then how the hell did this work? Is it smart enough to figure that out? That seems unlikely, but clearly, or maybe I'm full of shit. Maybe it didn't work. Or no, wait. Thread thread affinity. Oh, wait. Is that what I'm doing? Hold on. I'm calling, get affinity. Oh, that's why it's working. Because I'm calling pthread set affinity np, which does take a thread ID. Okay. This isn't dumb luck. This is working as intended. I just didn't remember or didn't notice just now. But I guess that passing... Okay, I take the thread ID here, but this should not be a thread ID. Do I even use this fucking function? Let's see. Get grep CPU. I was probably just being thorough, but am I actually using it? Oh, I guess I am. Get affinity. Oh wait. No, I'm not using this anywhere. Get affinity. Oh, I see. Getting the number of CPUs. I use it for that. Getting a CPU vector layout. Yeah, this is one of these things. It's like, kind of a pain in the ass if you haven't thought about it. But you have this hierarchy of CPU cores in your system, right? So you've got all these on modern systems. You have these logical cores and then physical cores, and there's a mapping between them. What is it? LS CPU. Does that give us? No, it doesn't. Well, I guess yeah. So like here, you've got like this one NUMA node, all 8 CPUs are on that one NUMA node, and then I guess they don't. Do they? CPUs 8 online. Okay, they don't break it down here, but if you do cat proc CPU info, you'll get here CPU processor 6. Yeah, physical ID 0, sibling 8, core ID 2, CPU cores 4. And then you'll see, so it's right, so siblings is 8. Oh no, is that just siblings? Yeah, okay, there's 8 that are on the same die. I think that's what that means. And then there's CPU cores 4, CPU ID 3, and this is also this is CPU ID 2, and then CPU core 1, 0, and then 3 is back to 3, right? So this is paired with 7, 0 is paired with 4, 1 with 5, 2 with 6, and 3 with 7. So you have to like build this whole tree out, and you have to understand like physical cores versus not. And that's what all these, well, not here, but I have all these functions that I really need to move out of this module. But like pin threads, so P is physical, L is logical. So reader thread. So this is pin a reader thread to a logical core. Pin it to a physical core, which means it'll be on either of the logical cores. And then it gets increasingly more complicated because I have like 2 thread pools. So it's like read one, pin a read thread to one, what is it? Set affinity. Yeah, damn it, I forget all the names, but basically these all, it has a rhyme and a reason. Like read, pin, or to logical, physical. Oh, P is physical here. So read on a physical SP, I don't remember. But anyway, there's all these different ways of pinning threads to different cores, and you have to know the hierarchy and everything, so it's kind of a pain in the ass. So I need to, how did I do that? fuse loop. So I don't actually use get affinity directly. I do what, cores? What was the function? CPU to core, get affinity. Yeah, so this is where I build out the mapping. So I need get affinity. 0 means like all of them. So this, right, so this is fucked up. So this I need to fix. Actually, I might as well do it now. So this should be PID T. Let's align this. And then just do PID and PID. And let's fix it in the header. Get affinity. So this should be man schedule. Get affinity. Right. So this should be PID. Actually, let's double check something. Man pthread set affinity. Is this? Oh yeah, there is a get affinity. CPU set, but is that for the can you get it for all CPUs? Maybe that's why I had to use the two different ones. Get a function affinity for a thread in the buffer pointed to by right, so you want to do this is awkward because you want to get the layout of all the process. Like the process can be pinned to specific cores, and so you need to know what the operating system has allowed the process to run, what cores it is allowed on. And so you really want to get the CPU mask for the process, but then you process it per thread. And it's not like I have a list of all the threads, but I suppose you can I guess you could just look up you could get affinity NP, pthread get affinity NP on the primary thread or on yourself. But there's no guarantee that the thread hasn't been messed with. That's the thing. Like as yourself, you don't know whether or not your CPU set has been messed with. So I think I have to just keep it this way. So I would give it the PID or get affinity. Maybe I just get rid of this altogether. Right? Because if I'm only ever using it for querying this self, then it'll always be 0. Let's see, let's do PID T PID equals 0. And then get affinity. Yeah, I just hard coded to 0 here, so fuck this. Let's just simplify. Okay. Well, that removes part of the problem. Let's make sure it still builds. Okay, verify. There's a literal bug on my computer. Okay, so that compiles, and there should be no change in behavior there. And then gotta fix this. Let's well, first of all, let's just try this. Git push, grab this. Git fetch, set and make gmake clean. Sinbleed writes, does the file system support network file system? I'm trying something similar and using kernel packet or XDP socket for fast packet transfers, bypass kernel network stack. It depends on what you mean by support. So the file system is a purely local union file system, but it works with any path underneath it, right? So any branch that you give it. And so if you, what people will do is say, I mean, this is a little less common now because of the crackdown by Google and stuff. But for instance, what people would do is they take a local hard drive, formatted extension 4 or XFS or whatever, and then they would use like rclone mount, which is Fuse as well, and then mount like a G drive, right? One of those unlimited G drive accounts, and they would copy kind of semi-static, media kind of files to the G drive account, access it as a POSIX file system through rclone, and then with mergerfs put both a local drive and the network rclone file system together under one pooled view. And so in that sense, it supports network file systems. People will add Samba or CIFS shares and NFS and take your pick of network file systems. Like you can use mergerfs with it, but mergerfs itself is not a network file system. There's far too, like, people have asked about doing that, and I just don't think there's merit because there are just too many network file systems out there. There's like dozens, and I would be in competition with like companies. It just wouldn't make sense. The only thing that I've considered doing is creating, it's on my to-do list, is maybe create a very simplified network file system that is totally insecure and based on Fuse and just is like point-to-point kind of setup where it doesn't try to do anything smart. It understands its place in the world as just like an unsafe, simple network file system. And as a replacement for like NFS, which has certain baggage, and Samba, which, if you're using CIFS, I think they've removed all the POSIX compatibility from that. And so you can't really, you're not going to have POSIX compatibility with a Samba share mounted in Linux. And then your other options, well, there's like SSHFS, and that's kind of that's it at the moment. Because, for example, if you need synchronous replication with while your file system on node 1 needs to replicate, I feel using kernel socket layer is slow. Better to inject packet directly into the kernel. I don't know. Linux networking is pretty damn fast. Now I've worked in high frequency trading, and in high frequency trading, they bypass the kernel, but they are also in high frequency trading where nanoseconds count, and they are literally pegging a CPU core running at 100%, removing all interrupts from being managed by that core. So effectively, there's no operating system anymore running that particular CPU core, and it does nothing but poll a network device to get packets off of the wire as fast as possible, and then send them back as fast as possible. So that's a pretty niche scenario. And sure, right, like you might get optimizations that way, but I certainly wouldn't start there when trying to build a network file system. Exactly, it's only IRQ which on the driver to offload on NIC. Yeah, I mean, I would say if you're building out like some crazy ass high performance network file system for like, you know, extremely high bandwidth storage where you've got 100 plus gigabit NICs, or maybe even just like 25 plus gigabit NICs, and you're expecting to saturate them, and you want the minimal latency on everything, then yeah, like I can see that. At the same time, how is that going to be deployed, and how much is that going to mean at the end of the day? Because, for instance, I worked on a project years ago where we had all this grid compute, and we noticed that storage was extremely underutilized relative to other things, like CPU and RAM. And so we considered the possibility of using like a distributed file system to eat up that storage so that people could leverage it. But the reality is that a high performance storage requires high performance RAM and CPU as well, and network cards and everything else, right? So you can't really co-locate the high performance compute sharing, or sorry, the high performance storage sharing with the compute. Like, they have to be separated. And so by that point, you basically have a cluster for compute and a cluster for storage. And so you still have to go over the wire anyway, and you're going to be limited by the consumption side. So, plausibly, any of the optimizations you do within the storage cluster are going to be lost, perhaps, on the consumption side. Actually, my main project is endpoint-based data loss prevention solution where I do deep packet inspection in the kernel. Interesting. Data loss prevention solution with deep packet inspection. Are you using like whatchamacallit, ePBF and or is this like bespoke drivers? Okay, cool. I haven't played with ePBF much, but there's been talks for years now to try to incorporate ePBF into Fuse, and I don't really know what that would look like at the end, but people keep talking about it in relation to making it so that you can do more pass-through in Fuse. So there's the pass-through feature that exists today as of, what was it, kernel 6.9 earlier this year, where you're able to associate, so part of the protocol now is that you can associate a file descriptor that the Fuse server has opened and hand that off to the kernel and associate that with a node in the Fuse node tree. And then certain, basically just reads and writes, will be bypassed. Well, the kernel will see that there's this file descriptor associated with the node before it decides to forward on that request, as it typically would to the Fuse kernel or the Fuse server. And so it will give you near native performance when you do that, right? So because you're passing by Fuse, not Fuse altogether, because it still has to go to the Fuse driver. The Fuse driver is cutting the Fuse server out of the equation. The problem is then you don't have control over what's happening. So if you get an error on the underlying file descriptor, tough shit, right? Like you don't get the opportunity to mess with the response back to the kernel as you would normally. And the idea is to use ePPF, I think, to expand on that idea and to make it so that you can put rules in the kernel in ePPF that will decide, okay, what commands go to the kernel, stay in the kernel and get redirected, which ones go to the Fuse server. I got the random set idea to have a distributed file system that acts like RAID 0, but over a network and writes single bits of data to multiple computers. Yeah, I mean, your wishes. The biggest problem there is that as soon as RAID 0 is complicated, is mathematically not complicated, but as soon as you add the network in, it becomes very complicated, especially if you're expecting to have any sort of synchronous writing. Your best bet would be to not do that. But if you look in the enterprise space, you have stuff like that does effectively, full byte level replication in real time. And I forget what the product is that I have used it at where I work at Morgan Stanley, but it's basically you have to have a fiber connection between two data centers that is less than, 20 kilometers? And so as long as you were within that guaranteed, and it's like a hard real-time connection, that synchronous connection between the data centers, then as you write to the SAN, it replicates to the other data center in real time. So by the time you get an acknowledgement back, it's already been replicated. So there's a number of technologies out there. But the thing is, nowadays, that is just less and less important because of the way people design their data platforms. Sync bleed. I always think you cannot get both. You value latency when you value security less. For stringent data loss prevention at the endpoint, with no data loss, you need to compromise over latency. Otherwise, if you value latency, use firewall, but still L7 firewall. Oh yeah, sure, certainly, right? Like nothing is in life is free, and physics gets in the way of all these things, right? Like if you care about latency, then almost certainly you have certainly you have to give up a certain amount of security effectively, and vice versa. Gyros Geyer, similar to how on Windows file system drivers only return a block mapping, the actual accesses to the file data never touch any file system driver code. My current project is building something that can speed up my virtual machines. On the lower levels, I want PCIe virtual functions so VMs don't need to bother the host with their I/O, but I still want to share the data between them easily. Oh, interesting. What are you building that on top of? Like, which are you using? Like, is this Linux or Windows? And what hypervisor? Is it just QEMU or something with KVM? Okay. I need to get. Hold on. Let me see. Can I keep looking down? Because I've got my I've got a phone below my camera, and that's where I'm reading all the stuff from. And an FPGA that maintains the queues. Wait. So you're. Wait, so you're virtualizing the PCIe bus, and you're saying, are you feeding that into the FPGA, which basically becomes a like fake PCIe bus for just the virtual machines? Break out this pop out chat. The FPGA pretends to be 255 devices. And these get passed down in different VMs. What device is it pretending to be? Oh, okay. But will become NVMe. Oh, okay. But you said but I still want to share data between them easily. So, I mean, if you're using NVMe, how are you sharing? Oh, Gluster FS, really? People still use Gluster? I thought that had kind of fallen away from favor, even from was Red Hat. Or was it Red Hat that maintains Gluster FS? Or am I thinking something else? Because I remember whatever the one that Red Hat bought several years back. I think it was Red Hat. It's the only thing that allows multiple mounts, I believe. Oh, is in like file system mounts rather than block level mounts? Because let me look this up because it's been a long time since I messed with this Gluster FS. Gluster open source. Let's see. Yeah, it was acquired by Red Hat in 2011. Because I think this has to be what I messed with years ago. It's also been a long time for me since I used that. Yeah, so that story I was telling about how we had this cluster of machines, and we were trying to leverage the storage for them. I had played with Gluster at the time, in part because Gluster, if this is what I'm remembering correctly, is not actually that dissimilar from mergerfs in that what they did is they expected you to, if I remember right, mount everything as so you would take a normal device, whatever block device, you would format it. I think it was XFS, and they had these agents that would talk to each other and do whatever the back end logic was, but ultimately the file, like the way the data was written to storage, was as a normal file system. And so you would, if you could log into the host and just see a bunch of files that, like, if you whatever, there's different modes of writing. So if you wrote a file in the mode, if you put the cluster in a mode where it like duplicates everything, right, at least once, then, and let's say you only have 2 storage devices, it would write the same file to both of them. But like literally it was writing a file to XFS the same way that any other piece of software would. And then they stored a ton of, and the reason they used XFS was because they stored a lot of metadata as extended attributes in on the file system, and XFS has I think about the most performant extended attribute capabilities and performance wise. So yeah, and it just fucked up all the time. I could break Gluster easily by just changing things out of band, or if I brought down a node, it would go into some bad state. And so we ended up just giving up on the whole project because it was just too fragile. Because we were working on a set of hardware that was fragile. It was intended for grid compute, and machines could just go down or be rebooted at basically at random. And so if all of a sudden you lose a storage node and that causes your cluster to go into some weird state, like that's just totally unacceptable. And the compute requirements were too high. It was too much of a noisy neighbor. Last time I used it was called GFS, 4 workstations in the same SCSI bus, but in principle should still work, exposing the same data on multiple hosts and allow the hosts to talk to each other, and then they can read, write, mount the same volume. Yeah, I mean, as I recall, like it says here, Gluster provided, so you could mount it over Fuse, or they had an NFS-v3 protocol server built in. And I was using it over Fuse, but I was working mostly on the back end. But if I remember correctly, I mean, I wouldn't be, let's see, stable release 2023, so it's a little old, but it's not that old. I mean, we use Red Hat at work, and I was under the impression that Red Hat has kind of given up on Gluster. That, like, whatchamacallit, I think they prefer, which one was it? This is just, yeah, this was always confusing, Luster versus Gluster. Ceph, right? Like, oh yeah, so they also acquired the Ceph. So I think they've been favoring Ceph. But in principle, oh, I already read that. Does ZFS do multi-mounts? What do you mean by multi-mounts? Use undeclared identifier. Okay. Because multi-mounts, different file systems use different and different OSs use slightly different terminology. So just so I understand, I mean, I'm no expert in ZFS, but just so I understand exactly what you're asking. Let's try. It's almost 9:30. Wasn't I supposed to get a delivery today? Well, I suppose it's a bit weird. But in Gyro's case, I assume it's a single physical drive with a single volume that needs to allow concurrent read-write operations. I know in Linux you probably fstab multiple mount points to a single storage pool, but I don't know if that's solved. So I think current read-write from different hosts. So not remotely, right? So typically a file system, you have a block device, and you can carve up that logical, whether physical or logical block device, and put a file system on it. And that file system assumes full control over the underlying device. Now, if you only have but that device might be a logical device like a partition. But in terms of being able to write to that file system, you're going there. I'm not aware of any. Let me think about this. Okay. There's no traditional file system that has network capabilities and allow, like, in the sense that the, like, ext4, ZFS, whatever, where, like, internal to, like, the kernel driver, it supports the network like some sort of network technology, as well as like a local behavior. Typically, you've got a file system that is formatted on top of a block device and is like a kernel driver that does that. And then you have stuff like ButterFS and ZFS and Riser 4 and stuff, which were both volume managers and so they managed the block devices and they were the file system in one. But typically, you either have a fully like a set of services typically that represent a network file system where it's just a piece of software, a service that then you have to have some kernel driver that speaks to it, and then it deals with any type of multi-tenancy and multi-client, which is really complicated because POSIX file systems are not designed for high relative latency that a network provides. And so that's why typically what you do is you create a block device, right? A logical block device on the storage system like Ceph, right? Because Ceph is more of a block service you first start with a block device that has exclusive access to that block device. Only one thing can access that block device, and then you put a file system on that, and then you're accessing that file system like with Fuse or something, like in the case of Ceph or GlusterFS. So it's still a single tenant situation where you've got this volume that is being passed around, and it's not terribly dissimilar from if you're using like a virtual machine technology where you have block devices that are remote, like ESX, like VMware, right? Like you will create a volume on the server that's a block device. You're sharing basically blocks over the network, and then the local device, the local server is turning that into a file system, right? It's treating that, it's just a block device over the network. When you talk about shared file systems, that is a whole can of worms, and that's where you get like Samba and NFS and etc. that have to try to do POSIX-like things in a way that just is extremely complicated because of the way the POSIX file system requirements are. And so that's why NFS is like a nightmare for locking, and like certain attributes of a POSIX file system just don't play nice with the network. I don't know about Linux's file system handling. It has this whole sync thing. I'm not sure what you mean there. There's a horrible monster that's called GFS and would support that. Multiple SCSI initiators in the same bus, and they would address disks and coordinate with each other of the same SCSI bus. If I remember correctly, the code got merged into early versions of GlusterFS, trying to avoid copying data around the network between VMs that all access the same underlying storage. So if I copy a VM A to VM B, it would fetch data over the network from storage, give it to the VM, which gives it to the network card, which copies it into the other VM, which then takes the data and gives it back to the storage system. That is kind of silly. I mean, I hear what you're saying, and certainly there might be situations where that could be better than other solutions, but I kind of feel like that's a little niche. In the sense that, like, what's the statistical likelihood that you've got that kind of workflow? I mean, all of this is very complicated. What was it? L:/Q, right there in yesterday's stream of his, there was someone talking about like a storage problem or like a distributed compute problem, and the thing that I was and some other people were trying to explain to the individual was that it's anytime you're talking about data over when the latency is high is Like it's very, very specific to the use case on how you can solve the solution or how you can create a solution in any meaningful way. Okay, so the FPGA provides more queues, more IO MME groups. Yeah, I mean, in some ways that doesn't sound too dissimilar to, in enterprise virtual machine deployments, right, where they are using storage services over the network to provide local disk, right? Like the boot image, the boot disk of or extra disks, local disks from the virtual machine's perspective, you got this local block device that you have a file system on, but ultimately it's really connected over sometimes a dedicated NIC channel to a storage server, um, and uh, and so it's not even. I mean, you still have to go through the PCIe bus there, right? But to get to the NIC or the shared NIC, depending on how it's set up. But I'm thinking of building a horrible transfer offload contraptions. Imagine a GPU. Are you just referring to bypassing the PCIe bus? Because if you're talking, I mean, if in that case, yeah, right. So you have like NVLink that allows like NVIDIA cards to have a back channel rather than going through the PCIe bus. In fact, I was just about to get a purchase order for some badass, still badass until Blackwell comes out. Gonna be getting some H100 NVLs, some a couple servers, 4 H100 NVLs each with connected over. So 2 sets of 2 in a server with NVLink between them, each 2 cards, with each card has 96 gigs of VRAM. And then, yeah, the NVLink gives you optimized access to the cards. And then if you're using what the hell do they call it? NV switch, which is like a basically direct to GPU switching a network between GPUs. Oh, you're referring to that. Oh, this compiled. Okay. Make sure this works again. Figure out what the hell I did too. Right. Okay. So I just need to add or whatever. I just need to add, where is it? If def FreeBSD include pthread np.h. Let's try this. Get fetch full clean, gmake clean, gmake. Last time I played with VMs and GPU, it was really basic and I couldn't really do hardware acceleration. Either you had to do give a VM the entire GPU or forego the hardware benefits. Might need to buy some new toys. Well, if I remember right, NVIDIA is, well, so in Linux, there's a couple technologies. What's it called? Looking Glass or something like that? That can, what did it exactly do? I know Wendell from like Level 1 Tech was playing with that for a while, a couple years ago. And if I remember right, there was, the basic idea was that you would render on the host. What was it? And that, yeah, I think you would do the graphics rendering on the host, and then transfer as fast as possible that frame into the virtual machine. Or was it vice versa? Whatever. But in any case, they tried to strip it all down so that it was as fast as possible. And they would render a frame and then basically mem copy that sucker as fast as possible into the virtual machine, I think it was. So there's that. But then like NVIDIA, I think, is starting to give up on virtualized GPUs in the data centers. Like, I think it's still supported, but they found that, I think it just wasn't, people want whole GPUs, they don't want half a GPU. And so the virtualization done in some of the older enterprise GPUs, I mean, I think that was part of the problem, right? Like workstation, it was supposed to be only supported on workstation and enterprise cards, and people were occasionally able to do it with non-enterprise cards. And there was like some error, I think, with Windows where they would catch it in the driver and fail or something. But I think generally they've been trying to move away from virtualized GPUs. Yeah, I mean, their focus lately, of course, NVIDIA's focus is hardly on GPUs in the traditional sense anyway. Right? Like if you look at an H100, it is not derivative of a, there's no gaming card that is derivative from the H100. Whereas if you look at the L40S and the L40, those are actual GPUs, right? In the traditional sense, in the desktop GPU sense. They don't have 64-bit arithmetic, double, right? 64-bit doubles. They, well, that's kind of the main thing. But there's a few other features in there that are, they have like more, they have less CUDA cores, and they have more tensor cores, etc. The performance of the whole card is lower in terms of megahertz because they're powering more complicated hardware versus the L40, which runs at a few hundred megahertz faster, I think, at least, like near 2 gigahertz or something. I forget. It's been a while since I looked at the setup, but yeah, that's why the L40S with its 48 gigs of RAM is good for like kind of traditional machine learning, large language model inference. But if you're doing any sort of high performance compute or training or whatnot, you really have to go with, ignoring the RAM considerations, you really have to go with the H100 variants of cards, or whatever the die is, the core of the H100. This is what they've got: the H100, the H100 NVL, the H200. Is that it? I think that's it. Okay, that seemed to build. So in theory, thread pinning works on FreeBSD. Let's rebase this. Double check the changes and then change the documentation if necessary. All right, so remove that, and shit should still compile. Let's let that run. And then added pthread there, which is good. Fix the get affinity and use PID instead of thread ID because that was not correct. Fixed all those. Add pthread NP, which gives us access to pthread set affinity NP in BSD. And that was right, generic Linux, since this is not just Linux only anymore. And then it's sufficient for building on FreeBSD. Threw in some NixOS stuff and reworded, separated out different distros, point to my docs, and then static binaries, which reminds me, oh, what was that tool shit that I was messing with? I was thinking about creating a static binary, what was that called? Dev. There's like this installer. Is it called like Run Me or something? No. Shit. I probably didn't leave a note for myself. I was experimenting with this the other day. Where you can create like a downloadable shell script that will, well, do whatever you want. And I was thinking of packaging up all the different variants of my static binaries, and then you can just run it. It'll figure out what machine it's on, and then just install for you whatever the right version is. But I could have sworn I had, you know, all my luck, or knowing my luck, I probably like played around with it in a temporary directory or something. Yeah, whatever, I'll mess with that later. Okay. Let's see. And then what else? Okay, FreeBSD install. That should be fine. And then the read ahead. Okay, that's fine. And then, so the unmount thing, oh, okay, I need to document that. Let's go to the docs, make docs. Make docs setting, or no, not, big. Do I have one for, okay, I don't have one for lazy. Shit, what the hell is the stupid documentation page? Traffic, was it localhost 8000? So config option. Oh right, I called it options. Lazy unmount. So I don't think I have a dedicated page for that. Lazy mount. Right, this is the only place. Okay, so let's go to options, find lazy, does not work on FreeBSD. Yeah, because there is no lazy unmount on BSD, on FreeBSD. Where the hell did it go? Okay, that looks fine. It does not work on FreeBSD. It'll just error out, which, you know, it'll still try to unmount it. Let me say, may not work on FreeBSD. That's because, so they don't have lazy unmounting, which is what this is called. So on Linux, you can lazy unmount something. As soon as the kernel recognizes that there's no more things trying to use that file system, it will then unmount it. Super convenient. BSD does not have that. So technically the code will run and just fail to unmount unless it's completely unused. I suppose in theory I could create another thread that just sits there and tries to unmount. Well, can I do that? Actually, I don't know. I'd have to get a handle to the underlying file system and then try to unmount it. I'm not even sure you can do that on, because you pass in the target as a path, not as a file descriptor. Because if you had a file descriptor, then it would be in use and you wouldn't be able to unmount it. So I guess that there'd have to be like name spacing or something. I don't know. I don't think you can do that. And then this mount I get. Oh, okay. Put this mount there, and then temp file removed. POSIX source. Do I really need that? Actually, maybe open at. Since. Oh, maybe I should not be defining that. Let's try that first, because maybe that was just not something I should be doing in the first place. Preload. Let's comment this out. Make preload. Make clean. Make preload. Note. Oh. Spell clean. Okay. So maybe I just didn't need that at all. I don't think I'd do anything, try to be smart and like not do something if it's not defined, right? I wonder why. Oh, you know, I probably defined it because of some like on ARM or something. And I'm going to learn the hard way that was important later. Shit. I guess I'll find out the hard way. Because I don't... do I have an ARM machine I can try building this on real quick? Do I? I don't think so. All my ARM machines are offline at the moment. I do have one ARM server from Oracle. Maybe I can try that guy. Okay. Git push. Let's maybe try that. SSH leave on. Git clone. No Git. Really? I don't have Git on this thing? Okay. APK and add Git. Git clone. BSD. Yeah. Well, we started talking with people, and I haven't finished the first part yet of trying to get to finishing up mergerfs port to FreeBSD. But that, yes, in theory, 3DO emulator work after this. Let's see, make preload. I don't have make. APK add make. Oh wait, actually, tools install. Build tools install packages. Actually, I probably need to fix that because I doubt I need all of those packages. But okay, that built, and this is an ARM machine, right? No, wait, this is not the ARM machine. Damn it. Shit, what's my ARM machine? Perl. Yes, this is the ARM machine. Okay. Git clone. Because of course ARM has some different syscalls than x86. Check out FreeBSD. Yep, mergerfs. And then make preload. Okay. That worked. Perfectly the width is height of the thing. All right, that looks okay. I think. Maybe it was 32-bit ARM that I had problems with. Well, I will just leave that commented out for now, and in case I forget later. And I do find that it was a mess up somewhere. Git push F. So I think that's the only documentation, the only thing that's broken now on FreeBSD. Oh, I do have to mention, shoot. Do I even mention this in the docs? How, let's see, UID. I don't think I have a section on how this works in the docs. I thought I did at some point. Maybe I don't. Usage patterns, FAQ, technical behavior and limitation. Maybe here. Hard links. Let's see, set UID, no, EUID. Okay, I kind of mention what I do here in these docs. But not exactly. Maybe I should write a section on how this works. Let's write some docs, I guess. We want to go to FAQ and sure, this seems like a good category. Let's call this how does mergerfs handle credentials? That seems reasonable. how do I want to put this? Oh, I forgot to transition the changes I made earlier, because since the cat has left us. Let's see. mergerfs is a multi-threaded application. In order to requests from the kernel concurrently. Each fuse message contain has a header with certain details about the request, including the process ID PID of the requesting application, the processes effective user ID and group ID, GD. What else is sent? Let's see. Not that it makes too much of a difference, but mergerfs libfuse include fuse kernel. Yes. Header in header. Length, opcode, unique node ID, UID, GID, PID. Yeah, that's, I mean, those are the main three. Okay. The process ID, comma, and group ID. To ensure proper POSIX file system behavior and security, mergerfs must change its identity to match that of the requester when performing the core file system function on the underlining, yeah, file system. Typically, let's see, no. Let's see, on most Unix-based systems, let's see, let's call this Unix/POSIX-based systems, a process and all its threads are under the same UID and GID. However, on Linux, each thread may have its own credentials. This allows mergerfs to be multi-threaded and for each thread to change to the credentials as required by the incoming message it is handling. However, on FreeBSD, this is not possible at the moment. Actually, there was, let's see, FreeBSD per thread, yeah, here it is. Damn it. Per thread credentials. So this has been discussed in the FreeBSD community. Unfortunately, because I guess Mac OS pthread, what is it? Set UGID. Like apparently Mac OS has their own way of doing this, and Mac OS incorporated a lot from FreeBSD, but unfortunately FreeBSD has not yet stolen this feature. Yeah, so it has this this function, but I don't support I don't support macOS. So macOS apparently, or the FreeBSD wanted to add these functions, which I don't know why they wouldn't just reuse the same names, but they have not, in fact, added this. But I will link to it. However, on FreeBSD, this is not possible at the moment. However, there has been discussion. Let's see. Discussions to support this. Oops. Copy. How does credentials? However, on FreeBSD, this is not possible at the moment. Discussions. Let's just say though there's been discussions at the moment, and as such must change the credentials of the whole application. Limit how do I put this? And as such must change the credentials of the whole application when actioning messages. mergerfs does optimize this behavior by only changing credentials and locking the thread to do so if the process is currently not the same as what is necessary by the incoming message, incoming request. This is probably okay. It's got the word FreeBSD in there, so that'll make it searchable. And suppose I could try to add, let's see, credentials, change the credentials, make it a little bit more searchable. Set UID, set EUID, set EGID. Right, because that's ultimately what I'm doing. I get grab set EUID, set EUID. Yeah. I think I'm calling something different for Linux. is it source UID, source UGID Linux. That's not what I wanted. Oh, right, yeah, because I'm calling the real effective UID, I'm calling the syscalls directly. Because you can't, you have to, that's the only way to do it per thread, because if you call the glibc set EUID, then it triggers a real-time signal handler that can't be managed otherwise by the application, and then glibc is, or the libc is setting the values for all threads. It sounds kind of hacky, but that's actually how it works. So that's sufficient. I don't need to put in the specific syscalls. Linux syscalls anyway. All right. This will help explain it if it ever comes up. Status git commit amend. I can't spell amend. Push show. Da, da, da. Okay, one last time. Make clean. Make. Let's look at the docs. Back installation, FreeBSD. This goes there, this link works. And then build FreeBSD. That is approximately correct. And then I think that's it. Let's just do FreeBSD. Comes up where it needs to. Oh, maybe I should change that. Let's see. This is under related projects. Maybe. It's not a maybe anymore. Repositories of many Linux distributions and FreeBSD, because I don't think NetBSD supports mergerfs. And let me add FreeBSD, which was here. All right. I need to do another round of checks to see if mergerfs is supported anywhere else. Oh, I wanted to fix this. This was not working anymore. Let's... because I guess they change. Is there just a good way to search this generically without picking one of these channels? It doesn't... Can I just remove channel? Does it just automatically fill it in? Okay, maybe let's try that instead. Where'd Nix go? So we can from 0 side. Okay, these, let's default these. Let's get rid of sorting. It's probably sufficient. There we go. Now it doesn't bring us to a broken link anymore. Git commit. Oh wait, git Oh, okay, I did. And then push. I think we're probably good to go. Let's give it one more check here. Git fetch. Git reset. Origin. FreeBSD. Make gmake plain. And gmake. Let's go. And let's go to GitHub. Best. Of course, this is going to break the FreeBSD guy, but as soon as I release it, but he should have just helped me upstream them in the first place. It would have been better. One last look over. Okay, this looks good. Let's preload. All right. Just wait for this guy to finish building. Actually, I'll just create the pull request. For 3DO stuff, outside of the whatchamacallit, the announcement today of the FPGA core being worked on, I did get this in the mail this week. So this is the retro gem for the 3DO. So this is an HDMI mod for the 3DO. It was kindly sent to me by the folks at was it Retro or Pixel FX? I mean, I've bought their stuff in the past. Yeah, the Retro Gem Shiny Edition. It's for those who don't know, it's a multi-system HDMI converter, and they provide like different wiring harnesses for different systems, and so they recently added support for 3DO, and so I need to figure out which machine I'm gonna install it in. Probably my FZ1 with my I've got an Pixel ODE in it, or the external ODE actually, and I probably won't use that for development as much as my Sanyo, but I think it'd probably be nicer to put the HDMI adapter in a device that I put in my main TV instead of the one that I kind of just hook up for the purposes of stuff here. Like, do I have this set up? I don't. Let's see, is my I don't think I have a video set up right. Let's see. Why is it not even showing up on the screen? Oh, there we go. Wait, is it? Oh, it's behind everything? That would explain why it's not showing up. Let's see. How can I make this bring to the front? Order, move up. Control up. Why is this not showing up? Whatever. I'll worry about that later. I'm not showing off the 3DO at the moment anyway, but I'm thinking about just keeping the analog capture for streams and stuff and development work, because I prefer, rather than like hooking it up to an HDMI capture device and having to have a dongle plugged in for that anyway. I'm going to need a dongle for the analog too, and I really don't hook up audio unless I absolutely need to. And then, so there's only one wire from the 3DO anyway into the capture device, and it's all USB dongle, and then leave that for development, and then put the FZ1 in the living room finally, because it's been sitting on my desk here for 3 years. Okay, so it built on here. Let's preload, and that built. Go to build mergerfs. That looks like it's running. I need to update the license, copyright, that's fine, and then preload. That looks like that works. File, let's look at these, looks good. Shared objects, executable, okay, all that looks good. So in theory, this is ready to go, and I will need to add a FreeBSD build target, probably, to make sure I don't screw shit up in the future, but I'm just going to merge this for now. And then there's a guy who helped with my documentation, and he was looking to reorganize some stuff. So let me just leave him a message. Check out the latest build, latest in master. I've added FreeBSD support and added FreeBSD relevant aspects or relevant parts to the docs. Clean up the install section. All right. He's the one. So this guy, Oregon Pillow, helped me out with initial update to the documentation, which kind of kicked me in the pants to actually finish all this. Let's see, did it update already? Yep, there we go. Cool. FreeBSD done, at least done for now. Close. What time is it? It's only 10:18. I can stay on for a bit longer, maybe break out the 3DO stuff, see if we can do some debugging there. Close. All right. So it's been a while since I worked on Opera. So let's close some of this mergerfs stuff. You know what? It's just easier to close it all. All right. So let's open up a new window in Tmux. Not Opera. Was it RetroArch? Do I even have it on this system? I think I was doing a lot of development. Oh, there we go. Opera libretro. I was doing a lot of stuff on my laptop for a while. All right. Git pull. Really? Is it? It's totally. There's nothing been done in a while. Always format NVRAM. No. May of 2024. I mean, I don't remember anyone doing any updates, but maybe there was git pull upstream, git fetch all. Do I have upstream? Oh, okay, there are some changes. Okay, git pull upstream master. Pull upstream. Pull from, but master. Git just a make file change? No. Okay. All right. That's really it. Someone added tvOS. Oh, is that Apple tvOS? Apple support? I mean, that sounds right. Let's maybe bring up Opera lib retro. Let's just double check that I don't have it broken upstream. Commits. Yep, that's the last one. Okay. Okay, so the problem that we're trying to, let me maybe update let's just change the title of the stream for now. Just to 3DO emulator C. In C. People seem to like when you put more esoteric languages, low-level languages in the title. All right, updated the stream, and let's see. Okay, so the while watching the YouTube where the hell's the video? FPGA. While watching the video of the new 3DO core, a bunch of people liking stuff, reposting stuff. Lon Simon. Definitely connect with Trap Exit. There's plenty of active community. Yes. Repost. Yeah, repost. Matt followed me. Deep Fried Switch followed me. Okay. So in this video, there is towards the end, he shows off Super Street Fighter 2 Turbo. And for those who don't know, Super Street Fighter 2 Turbo is this is the port of this game for home consoles, at least for the time. And there is a bug in Opera that is the same as this. So you see here, the way this is rendering, so the 3DO renders in a painter's algorithm. And so you have a linked list of what they call cells, and it's CEL, not CELL. CEL as in like a cell of animation. And they have a linked list of cells in memory. And then you give a pointer to the beginning of this linked list of data structures to the MADAM, to the cell processor that is in the MADAM chip. And it traverses this linked list of what they call CCBs, the cell control blocks. So you've got this structure that is represented in memory. You point a certain register. I mean, you don't control this because the 3DO has a high-level operating system that abstracts all this stuff. But ultimately, what happens is that there's some registers. You put the values to the beginning of the CCB, like the very first CCB that you want, into that register. You tell the cell engine to beginning execution. And then it follows these, and there's a bunch of flags, and it points to a bunch of data, the cell, the actual raw data, the palette for that data, etc., and then renders it. It renders it in the order in which they are in that list, right? So if you're imagining a game, like a 3D game or even a 2D game, you're going to want to have to sort or create this list in the order in which you want them to paint, like in a painter's algorithm, right? So the thing with the least priority is first. Least visual priority is first, and then you have to paint in over it. And so what's happening here is this background, the Street Fighter 2 with the globe and everything, and I think even all of this down at the bottom, the characters select all their little icons. I think all of this is like a static image, and so this whole screen gets rendered, and then this mesh gets rendered. Now this mesh is actually larger than it appears, and for some reason I don't think they use it anywhere else in the game that I've noticed, but I think they actually render it like off the screen a bit, and so then it overlaps into the and becomes kind of narrower here. So there's actually like some here that's cut off, and then they render this white box every other frame or whatever the rate is, and it's literally just a white box. I think it's 12 by 16 pixels. And then they render the select game speed. Now this whole thing, this is not a font that's being drawn. This is an image that is, and all of this is combined. So the select game speed, 1, 2, 3, fast, slow, all of that is just a single image. And so that's how they render it. They put in the background, they put in the mesh, which has these transparencies. Well, actually it's, it's transparency. The 3DO doesn't technically support rendering flat out translucency. It does so by doing pixel arithmetic, which is why certain 3DO games have translucent looking shadows, whereas the Saturn doesn't, and even sometimes I think PlayStation versions don't. Is like it's technically hardware accelerated, but it's not exactly it's not an alpha channel. It's actually a combination of taking whatever the pixel data is from one source, which is typically like the current frame buffer, and then whatever you're rendering it, and then applying some fixed function arithmetic to it. So it'll be like a source 1 plus source 2 divided by 2, or source 1 times some value divided by some other value, or minus plus some other value divided by 2, so you can like scale them and create like a gradient and whatnot. But in this particular case, this is actually, I think, an uncompressed, because the 3DO supports compressed images in form of run length encoding. So this is like an uncompressed, where it's just like literally every pixel is enabled. Why they did that over actual translucency, I don't really know. I don't think it would have caused any performance issues. It's just there's not much being rendered on the screen, in fact. But in any case, so it renders the background, this mesh, the square, and then this. And clearly this is not, the select game speed is not where it's supposed to be. It's supposed to be over however many pixels, where the 1 would be right in the center here. And it's been like this since I took over ownership of the emulator, and I just have not gotten around to fixing it. I did look at it a couple years ago, but very, very briefly. And the interesting thing is that this FPGA core also has the same bug. And my speculation is that he probably, I mean, it's certainly possible that he went off and did all his own research and reverse engineered the 3DO, but that would probably be really stupid because we have a lot of information about the 3DO. It's actually a little surprising he hasn't reached out to me, since I'm kind of the holder of all this information on my website, and worked with folks like Electron Ash when he was working on 3DO FPGA work. But yeah, so it's plausible that he has just taken logic from the Opera emulator, and that's why it's wrong. So if I can fix it, if that's true, and I fix it in Opera, 1, I fix it in Opera, but 2, then he can hopefully get that fixed. So yeah, so let's see. First, let's just get our bearings here because I haven't worked on this in some time. So we've got this. I have this run script. Yeah, that just executes whatever my build is. And I should be able to make clean. Let's just build this. Okay, this looks good. There's a few other bugs that honestly I introduced not too long ago, but I simply don't go through and test like every damn game. So there's some games that after I added the ability to change the amount of RAM that the 3DO has, which is something that I hope that we can get in any FPGA implementation, because that would be really fantastic. Because I think, you know, an FPGA core for the 3DO is really going to open the availability of the platform. And if we can make it so that the FPGA and the emulator that I work on have the same feature set or pretty close, then that could allow more things to occur. And since the 3DO could actually handle, it was designed to handle, and keep this in mind, the 3DO was started design in 1989. So the fact that it could possibly handle up to 14 megabytes of DRAM and 2 megabytes of VRAM is pretty impressive. It, you know, it was designed to be forwards and backwards compatible to a large degree, and the operating system is quite powerful for its time, more powerful than Windows or Mac OS was. And the fact that you can, that they could have basically easily just thrown in more RAM and that, you know, call it a day. Like, can you imagine a machine in 1994 with 8 megs of RAM on a home console? I mean, of course it would have been expensive, but that could have been pretty cool. It's almost a shame that it wasn't user enhanceable. It would have been really neat to be able to put in a SIM into your 3DO if you cracked it open and add a SLIM to expand the memory. I don't think anyone's ever seriously looked into expanding the memory on a physical machine, but it was easier to do in the emulator. I had to change a bunch of hard-coded stuff, but it was yeah. So it was, the 3DO was designed as a architecture platform that would be licensed to manufacturers, and they offered it to everybody. They offered it to Nintendo, Sega, and in fact, Sega nearly purchased the M2, or came of all the big companies that considered it, they were the closest to considering the M2. But I think by the time that they offered them the M1 or the Opera, which is this system, the original, the one that we all know, they had already decided to start with the Saturn, I think. And so they weren't really interested. I think that's the story. And by the time 3DO and Trip Hawkins talked to Sony, they had already been designing the PlayStation, and similarly were not really interested. But yeah, so there's a reason why you have Panasonic, Sanyo, Gold Star, LG, and Creative Labs 3DO devices, right? Because they just licensed the technology, and then they would manufacture it. Now, of course, they're going to manufacture it to be compatible with the 3DO standard, because that's the whole point. And then, of course, you're just going to take a reference design from the company, right? So I think a lot of people don't realize that even today, if you buy a video card with an NVIDIA chip in it, right? Like NVIDIA was deeply involved in the design of that card, and then the OEM, not OEM, the board partner is taking that and then tweaking it probably, but still the core of that design comes from typically the original company that's selling that technology. And similarly, like, I'm sure Panasonic had some say in the design of the final product, but the core of the product had to come through 3DO. Probably why they allowed variable RAM config. Well, they always intended that the system would be forward compatible in some form. And that's why it has an operating system. And so it's kind of awkward, right? So you have to put yourself in their their shoes at the time. Certain like homebrew folks in the 3DO community, when they first get involved, they look at the 3DO and they're like, why the fuck does it have an operating system? I want raw access to the hardware. And I get it, but the 3DO was not supposed to be a single machine that was discontinued in 1996, and that was the end of it. It was supposed to be a new standard that for video games, the VCR of video games. And anyone could license the technology of a VCR and make their own VCR, and many, many companies did. And the idea was that many companies would license the 3DO technology, and you would have, just like PC compatible, you would have 3DO compatible machines. And so the idea was that over the long run, you're going to have a 4 megabyte DRAM system. You're going to have an 8 megabyte DRAM system. You're going to have a 2 megabyte VRAM system, right? Like you would enhance these systems. They would all be backwards compatible with the software, or the software would all be backwards compatible. And if they, given that it was a high level operating system, that would make portability to even a different architecture easier. So when they moved to building the M2 platform, now there is evidence that we have that there's actually an ARM core in the power, like in the Bulldog, in the Bulldog chip, I think. And there are what appear to be aspects of the original 3DO console, the Opera console, in the M2, but they decided apparently to just not use them and not make it backwards compatible. But originally it was supposed to be an add-on, and then it was going to be backwards compatible, and then it was just, fuck it, like we're just going to go and make it. But the operating system was more or less ported from the original machine to the M2. And that operating system is locked down. It doesn't allow you to have access to the hardware. The machine has an MMU, or like a simplistic MMU built into Madam. They call it memory fences. And so and the operating system runs at a supervisor mode, but then puts you into user mode. So you can't just like arbitrarily gain access to the hardware, because all memory accesses go through the fences and everything. So it's like, it is extremely, it's preemptively multi-threaded. Like it's the only thing that it doesn't have, which is a little odd maybe, is it doesn't have identity outside of supervisor and user, right? So it's just user space and kernel space basically, and then there's supervisor, and that's it. There's no concept of like Antonio or whatever. Trap exit is one user, and so and so is another user, whatever. But then again, it's a game console, so it makes kind of sense that they wouldn't actually have that. But yeah, file system drivers, controller drivers, all kinds of fancy shit in there. And then that came over to the M2. And yeah, so just for like variable RAM, and it's a 32-bit processor. It was the first 32-bit address spaced ARM chip. Before that, they were all 26-bit. Not that that would have mattered for the 3DO, because never got more than anywhere close to 26-bit, which is what, 64 megabytes of address space. But the operating system itself looks at a value in the Madam, which indicates what the layout of the RAM is. And how that value is set, I'm not exactly sure. I don't know if it's part of a startup routine or something, but it's a little unclear to me. I need to talk to Fixel about it, because he understands more about the hardware from that perspective than I do. But in the emulator, effectively, I just change that register based on what you put here. So these are kind of like basic compatible configurations. So it can have up to 2 megabytes of VRAM. The operating system can't understand more than that. It actually, basically what it does is it has 16 megabyte address space between like certain ranges in the address space where the actual RAM sits, and it's if you had like basically it's whatever the VRAM is subtracted from the top of wherever the DRAM is. So that's why you have like 14. You can have only up to 16, but you can't have 15 megabytes of DRAM and 2 megabytes of VRAM, or 16 megabytes of DRAM and 2 megabytes of VRAM. It has to be combined, that one. And there was a bunch of hard-coded shit in the emulator when I got it that made doing this impossible, because it was like literally, RAM, if a conditional statement, like if the memory access is between this range and this range, hard coded, then it's RAM. If it's between this range and this other range, then it's some piece of hardware or whatever. And so I had to go and make that configurable everywhere, and that took quite a while to find all those hard coded values, because a lot of this code is very hacky and bespoke and what have you. It's clear that they were experimenting while they were writing it, and then they released that rather than what came later, where I think they went back, started from scratch after they learned all the details. But yeah, so let's try to load up Super Street Fighter 2 history. Let's see, can I add desktop audio? Why is desktop audio not showing up? Oh, because I've got to transition it. That's pretty good. Actually, that's too loud for me. Let's see, can I lower the volume just on this app? Does RetroArch have a volume setting? RetroArch volume? Volume gain on the keyboard. Oh, really? We can just hit plus and minus? Does not seem that way. At least there's no visual feedback. This is just something says press plus or minus, but that doesn't seem to be working. Sounds, applications, RetroArch. Here we go. There we go. Now we should all hear it about the same. Right, so probably I just missed the bug. What time is it? 10:45. I gotta figure out why that logo flashes weird at the beginning. By the way, this audio being out of sync, this is not an emulator problem. This is the actual software is buggy. All right, see? So this is not centered correctly. Like the white box is clearly in the right spot, but that's not. Okay, so let's open up this code. Dev Opera. What's the layout here? So this should be. Where do we want to look first? Let's look in lib opera. And I have some notes. Let's maybe look at Opera Madam first. I really need to add my name probably here, because I've rewritten a lot of this code over the past couple of years. Let's see. Let's open my to-do list, because I've got some notes there that I took recently. So the clipping size of that frame is apparently 288 by 224, because it's +1. So it's clipping the rendering that way, and there's probably an offset somewhere, and the clipping looks okay mostly. But if we let's see, if we go do this again, actually, let's see, I want to run it with opt ROMs 3DOs Super Street Fighter 2 Turbo USA. There's like 4 revisions of this game. Bin. Thank you. Is that gonna work? Yes. Come on. This is this part here. So there's like this corruption up there that's interesting, and then this blinking, and I've yet to figure out why that blinks like that, because it shouldn't. You can see, like, I don't know if maybe the clipping is not right, but you can see this. So there's this full frame of black, and then they are rendering within this and making it, rather than 320 by 240, I think it's 288 by 224 for some reason. I don't know if that's for aspect ratio purposes, probably for overscan. But you can see there's these pixels that always render there in this corner, and I'm pretty sure that should not be happening, because I don't see that in the Phoenix emulator. Why does it fly up there? Shouldn't it fly on the map? That's kind of strange. What's another thing that's interesting, this layout in the background here, this is not completely static. So they are actually drawing, you can kind of see it there where so it's drawing, like, I think the background to a degree, and then at the bottom it's drawing the like lines to make the ground look like it's shifting. And then but then the creatures in the background, for some reason, even though they don't appear to move during the battle, they are rendered separately. All right, well, let's just pause that, and oh, all right, so close it. So, okay, the clipping, and so this is some details I got from the Phoenix emulator. So this is the cell. This is the mesh. So these are the details of the mesh, and then this is the white square. And I was confused at first because they would the positioning. So typically the 3DO uses fixed point, 1616 fixed point for a lot of stuff, and then 1220 fixed point for some other stuff. And I was confused at first because why would the position be negative 24, like x coordinate negative 24 and y coordinate 128, when clearly 128 was not like the right height value. But then I noticed this, where the mesh is rendered at negative 24 and at height 16, which is, oh, I killed it, but I'm pretty, you can kind of pixel count down and notice that it's at 16, the y coordinate is 16. And so this is negative 24, but it's wide enough that it overlaps. And then what this says is that the vertical vector of 1, horizontal is 1, and the horizontal delta is 0, which is these are the vectors that distort it. And so this is like, this means no distortion. So, but I noticed that because it's flashing, right? So when it's off screen, and this is what I saw when it was on screen. So 6 starting at 93 pixels down, 6 in is when it's drawn, and when it's not drawn, and in fact, let me start it back up so we can more easily see this. But when it's hidden, they actually move it off to the side of the screen and down for some reason. Which is interesting because you can just flag a cell to be skipped and not rendered. And since they're redrawing the screen every single frame, it wouldn't make any difference. So it's kind of an interesting choice. And these are the kinds of things that can make reverse engineering confusing, because they decided to do something clearly that is not what I would have done. That's not what I wanted to do. Damn it. Restart. Right? I would have just told the cell to be skipped every other field or whatever the flash rate is. And that's just setting a bit flag. Whereas they are actually moving it, and I think they aren't drawing it, but for some reason they are both not drawing it. But I'd have to check the flags. But I think they're skipping it, and they are and moving it out of the way. Okay, so if we do, what is it, X or just P? Right, so we can make this bigger, and maybe we can do a couple pixel counting. 1, 2, 3, 4, 5, 6. Yeah, so it's 6, right? So 6 on the x-axis, 93. I'm certainly not counting that, but you know, this is only 224 pixels tall, so 93. It looks about right. But then this guy is 0.16. So if this is 6N and it's 12 wide, then it would be at 18. And I think, let me see, can I bring it? Do I still have the old emulator up with the details? Unfortunately, I do not. I don't feel like running it again. But actually, maybe I have the cells exposed. Let's see. I may have dumped the contents of this image somewhere. Let's see. ROMs, 3DO, Super Street Fighter 2. So here's the dumped content. Oh, clearly I already converted a bunch of this stuff. You want Cammy's tongue? You can see everything that gets made up at the intro. Electricity, all the things. Let's see. Background music, characters, ending. It's possible that it's not even a regular cell, unfortunately. Because some of these games, it's interesting what they decide to do. It's sometimes the like in this case, like sometimes stuff will be packed inside of another file with a different extension and not the actual not like a normal 3DO format, which is curious considering that they do use the format in other places. Background characters. Yeah, these are all the ending stuff. Selection screen. Maybe it's in here somewhere. Nope. Huh. Interesting that the selection screen isn't showing up. Or that the like select start select game speed. Yeah, that's strange. Well, that's annoying. I wonder where that could be. Well, that doesn't help us. But so if that's 18 pixels in from the edge, that, well, this is part of the image. So it's more like, is this the edge? Maybe. So if we move this over here, how many pixels would that be? That's like, is that 3? 3, 4. No. 3. And then another, if this is 12, so then like another 6, 7, 8 maybe. So that would be 8 plus 4, give or take. So like 12 pixels. So this whole thing is maybe 12 pixels over. And this is what, 1, I zoom this in, maybe more. How many pixels from S to the edge? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that might make sense. Let's see, how far is this away? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, this is hard without having the original image. Let me double check this again. Yeah, this is all ending stuff. Huh. Pick. Of course, Cammy, Faye. Okay, these are like different characters. So that's just the background in the other screen. Sound effects. Yeah, this is kind of annoying. That one damn graphic, this one screen is not obviously in any particular graphics pack that was convertible. Got all this just for the title. But not this screen. So this has to be embedded in something. But why? Oh well. So it's like I don't have an example of it working correctly. Maybe I do need to run this emulator. Let's see. Power this on. Play. That seems not the right resolution. This is in a debug mode. Let me fix the audio. Lower that a bit. So let's see how this looks. Pause. All right, so it's idle, but we want it to be busy, so we actually get representative. See the CPU doing its thing. Maybe if I... Come on, give me... Oh, shit. I missed it. I don't want to wait so long for this thing to come through. Come on. Too many things happen before it renders. There we go. Okay, this should probably... Oh, that's interesting. It's still got a bunch of stuff it thinks it sees in memory. Let's see. So here it is, right? So this is the blank cell, or this is the blinking cell. It's before it's rendering, so that's why we don't see it here. But this is indicating that it will render this white cell, and then we can see this is at negative 2416, so that's the mesh. That seems like 16 pixels. And then it's offset by negative 24. And if we look down here, we can see here's the mesh, right? So the mesh is 96 by 112. So that would mean... So if it's 16 down and it's 112 tall, this is this negative 24. How wide was it? 96? It doesn't look 96 by 112. It looks wide, way too wide for 96 pixels versus 112 tall. But if it's 96 minus 24, 72 wide. So here's the background. So that's all one screen, and this is the white cube, and here's the character select. So this is 84 by 112. So this is as tall as the mesh is. Really? That's interesting. And then you can see it's 1 pixel in from the left and touches the right. And so it's 90, or sorry, it's yeah, so this is 84 84. Let me put this in my notes. This will make it easier, hopefully. So this, first of all, let's do width times height. Width times height is, what did it say? 96 by 112. And then the white square, width times height, is 12 by 16. And the select speed is selects is 84 by 112. And so the mesh and this are the same height. And then this is offset. Does that make sense? This is 16 height down minus 24. So if that's 96 minus 24 is 72. But this is 84 wide. Huh, really? You would think, let's look at the and so this part is supposed to be 72 wide. Because it's rendering at negative 24. But is that negative 24, and then I don't want to have to pixel count this, but I suppose I can screenshot it and do it easier. Let's see. Copy, let's open GIMP maybe. It's saying, let's cut. Nope, that's not what I want to do. Actually, let's do image and canvas size and width. Oh wait, no, not canvas size. We want what? Crop. Image. That's. Oh yeah. No, it should be canvas size, right? That's. Don't lock them together. Oh no, I don't want them locked together. Crap. Reset. Offset. Oh, let's see. Reset. Unfortunately, this is. I need this to be zoomed in. I can't zoom in. Oh, I can't. This is not going to be pixel perfect anyway because it's already zoomed in on the screen. Can I make this 1-for-1? Then it's going to be fucking tiny. Yeah, this is too much of a pain in the ass. Fuck this. This doesn't look like 72 wide. And if this is supposed to be 84 wide. I mean, the height would also imply that this is like a bunch of white space, which is certainly possible. I mean, they might have just made them so they perfectly fit overlap each other. I mean, it's 11:15 almost. Okay. It's 84, but it's not offset at all. So this has to be right on the edge. So it's only 1 pixel in. So this is rendering a full 84 pixels. Then where's this 96 coming from? So there's minus 12. Unless that's related to, unless there's some change maybe in the clipping. Because the clipping is the width of 2. No, because the width is cut down from 320. Right, so so it's 320 minus 288. So you're 32 pixels total. So you're 16 pixels on this side, 16 pixels on that side. So 16. Why would this damn thing be offset? Where's this? Where am I doing math wrong here? So if it's minus 24, the mesh is clearly being drawn. That's got to be the mesh. It says it's 96 by 112. So I'm assuming this is 112 high. But this is not 96. And actually, maybe if I do RetroArch, if we bring this down, this is like the original size. And if I do, it's so small I can't even see anything. What is images? I forget how to take a screenshot. Let me look that up. RetroArch screenshot. How do you take a screenshot? Quick menu. Oh, take screenshot. Quick menu. There we go. So maybe Super Street Fighter PNG. Find name Super PNG. I don't know where that gets saved. Is it? Oh, it's Flatpak, so it's probably under bar. Whatever. Let's name Super PNG. Does it get saved there? Yes. Why is it open up in the browser? Stupid ass thing. let's see. Let's GIMP. Oh, because I have it installed via Flatpak probably. Open. Bin var. Really? There we go. Oh, it's locked down, of course. All right. Stupidest thing. And this is why Flatpak is a pain in the ass. Copy to temp. Where can I not just go to the temp directory? Jesus Christ. Oh, this is doubled, isn't it? Yeah, 240. Sigh. All right, let's try this again. It's integer based. Okay, let's try this. Quick menu. Take screenshot. GIMP. Open. This guy. There we go. All the pixels. And this should be 320 by 240. Perfect. All right, now we can do some pixel counting. Does this give it to us? Yes. $72. Set it said rectangle 72. Okay, so it is correct. So that is 72. This should be 112. 112. 72 by 112. So that makes sense. It's at a, let's bring back the details. So 72. So 96 minus 24, 72. So it is 72. It's just that this is off. So this is 12. It's being drawn 12 pixels too far. And so instead of position, which should be 0, 16, it's 12, 16. And I can probably do a really ugly hack to confirm this. So let's look at the code. We want to CCB pointer. What is right here? The next pointer. So this is the main cell rendering loop. And I went through this and commented it all a while back. So this, we would want the next CCB. Get late. So where, okay, current CCB P data. So I think the look at the README file. This should be, this is the address of the actual data. So this should be the P data. So P data equals this. So at this point, I think, let's see, if P data equals 1316C0, printf hello. And this should go ape shit, assuming that's the right value. So let's try building this. And then run. Nope. History. What did I not? Oh, I ran it up here. That's why. Let's see. Does this freak out once we get to this line of code here? Yep. All right. So that's a good sign. So that's the correct address internally for the P data. So when the P data equals this value, then we know it's the select game speed. So let's move this to where, okay, plut data. So the plut data, and then X and Y coordinates. X position are written to 2 memory mapped hardware registers, each having, right. So I think a lot of this details comes from the patents. So there might be something wrong here. So if the flag is skip, hold on, if it's clear. So if it's not skip and it's YOXY, right, which means I think load those values, then it's grabbing the X position and the Y position, and that should be these guys, this here. So in theory, it should be 016. So let's put this here, and then we'll print xpos equals let's just put it in decimal, or decimal in yeah, decimal, and then y position equals d, and then we want to do xpos 1616 shifted, or shifted right 16, and then xpos, or y position shifted 16, and that should give us, that should be the offset, which should be 016, but it appears to be 1216. All right, make fast forward. Okay. So where is it being rendered as 12? Okay, well, it's not 12 there. is the value is, so this would be the x position. So x position, where is this modified? Okay, it's used in a few places. Let's okay, this somewhere it appears to be getting, maybe I could put it in the debugger and watch the value. Kind of needed to trap us when it's a, so it was certainly reading the correct coordinates. So it's reading 0, 16. And then none of these should impact the value. X position 16, 16. Defined, this is where it's captured. Okay, cell origin VH value. Get the VH value for the cell. This is done in case the cell later decides to use position as the source of its for the projector. Okay. So this is one draw packed cell, and this cell is, let's see, what is this cell? Is it cell packed or not? It is indeed a packed cell. That kind of makes sense because there's lots of transparency, so that would be more efficient. So we should end up here and draw a packed cell. P data, all this code really needs to be rewritten, but it's kind of a mess, and so rewriting it requires some care. And I know that like this, the bit reading functions and stuff are really not optimized. There's probably better ways of doing some of this stuff. But okay, so X vertical. So let's maybe put this here and confirm that at this point it is still 0, 16. I suspect it will be. Maybe I should take a memory capture. Yeah, save state, load state. Okay, load state. Save state. Okay. All right. Okay, so it's the same value here. Maybe there's something wrong with the decoder. Switch texel draw function. Draw. See, the thing about this code is that it's very, like, there's a lot of globals, and the code is pretty verbose, and so it's very easy to get lost in this particular code. So, all right. We've got test init visual. Where does textile? So first of all, just double check this function. This is draw pack cell. Okay. So where textile draw function? Where does this get set? Right, init line map. Okay, so init line, and then this. Oh, right, because there's optimizations here. It's been so long since I looked at this code, but the now whether the 3DO actually does this or not, I don't know. We're looking at having the chips delidded so that we can, aren't delidded, whatchamacallit, damn it, I'm blanking. It's too late in the evening. But we're looking to get the layout of the chips reverse engineered, but the code itself here is optimized in case it's like unmolested, like the vectors are not messed with at all. And then if you're just scaling it, and then if you're like distorting it, so which is why certain games performance is worse, because if it's doing a lot of arbitrary manipulation of cells, then it's going through a slower path. But okay, let's, so it does, if we look at test init visual, it is packed, and so we checked after that, so this isn't manipulating anything. This is just checking to see if it's clipped or not, primarily anyway. And then init arbitrary map. Wait, is it initial? Okay, it defaults to line, maybe. Okay, well, let's function. Maybe if we do like this, let's just confirm. Just D, and we want it to return textile draw function. It's just to make sure. Okay, so it's yeah, because it's not scaled or anything, so that makes sense. So we're doing the optimized route that just draws it. So pixel count for row is 0. Row is less than the texture height limit. Row plus plus. P data equals offset plus 2, last address. Okay, this is decoding the packed pixel format. Is it this guy? This has to be it, right? So if X is being put initialized with X position 1616 and X vert, right? So that's X vert. And then immediately we get X vert plus VDX 16, right? Like this doesn't appear. Again, there's global stuff, so who the hell knows if any of these functions mess with it, but so let's do xvert here, xvert or yvert, and then let's see. So then we want to check. Oh, yeah, whatever. And we can see how these go up. But this would also, while end of line. So, I mean, if this is causing it to go 12 pixels ahead on the very first beginning, then maybe that's somehow it, but I don't know. I mean, maybe that there's a, oh, let's just see first. No. X position does not change. Let's try this again. Pause. So we've got, okay, so this is where it starts. Y position is 16. That makes sense. It should be 16 down from the top. But the X position here is still 0, and then it draws each line from 0 to the end. So why is it offset? Is it the decoder is off? Maybe? 12. Is the value 12 relevant in anything? Not that I can think of. Okay, so this, so xvert seems correct. Is there, let's double check the final pixel drawing location. So, well, not end of row. Read 2 bits. And that's, so that the packed format is like 2 bits to indicate an instruction. So the instructions are either it's end of line, it's a literal, it's packed, or it's transparent. And so that's what this is. This is getting one of those 4 values. And then let's just expand this out a little bit. Type, okay, so it's just saying if it's at the past the end of the address, then it should force it to be type 0, which there's a lot of this in the emulator, unfortunately. Really, this should be like end of line, you know, some macro that equals 0, but of course, but you know, there's all these magic numbers in here. So then it gets the pixel count, right? So there's 6 bits of pixel of the count plus 1, because it's if 0, it's always plus 1 for the count. And then if what's sci p? Oh, texture with start. Height start minus p data equals last. Texture high start. I need a height start. I gotta double check what that means. Okay, texture. Oh, this is for the clipping, I think. So if it's end of line, break. If sci pw, the hell does that mean? I forget. Sci pw, what the hell is sci pw? Word count. See, this is why I like generally using long variable names. Word count. Well, not end of row, blah, blah, blah. Texture, it'll start. Oh, this must be, yeah, this is the screen, screen pixel width, maybe? If, right, so, because otherwise it just, where's the condition? And, oh, if it's 0, it just doesn't do anything. Pixel width, 0 break. If it's greater than the pixel count, subtract the pixel count. Right, so this is where the where the vectors come in. If type 1 skip continue, somewhere it jumps, maybe it's this value. Where's the actual writing happening? Bit reader. And then there's this stuff that's been commented out for years that it's unclear why, because there's no notes. It was just commented out from the beginning when I got the code. Word count equals pixel count if greater than pixel count. See, I just don't know that I trust this rendering pipe, this decoding pipeline. I might have to just start from scratch maybe, but so okay. And so again switch on the type. End of row equals true. Break. Packed literal. 4 pixel. So this, I think these would all be, this is probably all literals because there's very, oh, maybe it's not. Actually, the fact that, now that I think about this, the fact that this is packed cell is a little strange. Oh, no, I'm not. I'm thinking of the mesh, not this guy. Okay, the, this is for the text. So this is going to be a whole lot of transparent, this guy. So it's going to skip a bunch of lines until it gets to here. And since these are, this is 96 wide, and the maximum run length is 64, so it's got to be at least 2 entries, excuse me. So there'll be, it'll get one of these, it'll be a transparent, and then XDX by pixel count. So yeah, it's skipping those, but if it wasn't skipping them, okay, it calculates the current pixel color. If transparent projection, if it's not transparent, draw the textile line from the current color, this X current, Y current pixel count. So maybe this is where we need this. This guy. And we need it to be x current, y current. So this is going to be a decent amount of data. But this should cover here. And I guess I could do the actually, maybe if I just put it in the transparent first, because we know that we're getting the transparent. So we'll do this. Because it's still going to be transparent down here, right? So when it starts rendering, it's transparent until it gets the 1 or whatever, like up here. So there's still going to be a part of it that's transparent each time. So we can check this here, and then it adds this. So maybe do it twice, once before and once after, just to get a sense. Do a whatever. It's fine. And do this. All right. Where does this start? Oh, look at that. 0. Zero. Okay. Oh, wait. Exposition 0. And then, hold on. Let's find a Y position of 16. Yep. Or whatever it should be. Y position, here we go. Y position 16. And then Y position 41. Why would that? Oh, is this just because it's... No, it shouldn't be. Y position or X position 0, and then I think it jumps because it's rendered 20. No, it's not 24 pixels in. It's 16 pixels in, right? So, let's. It jumped to Y position 41. Is it just skipping? Oh, it might be because these are all end of lines. That's probably why. Or end of row, I mean. Right? So this is printed at the beginning, but then it's every Y position, every row is just empty. It's a completely blank line. And so you can just say end of line immediately. So that's why that's happening. So it starts at position 41, and then that's where we get transparency for 24 pixels. And then it's, I can't exactly zoom in too well here. Right, but...
Chica just followed.
Thank you for the follow. So what's happening here is you'll see position 0, and then it's 24 pixels to here, and then 4 pixels of white, and then 1 pixel of transparency, and then 1 pixel white or whatever that color is, 1 pixel transparency. So you can see 28, 29, 30, and then 30. So this is probably 29, 30, 31, and then 39. Right, so this is drawing this first line at the top of select. But it is further in than it should be. So actually we want to see here. So this appears to be the bottom. We run it again. Like we always see it end at 118. So 118 must be down here, like at the end of slow fast. So this very tip of S and L, O, W, right? So if we look, this should be one. If we looked at where'd it go? Not this. This. We see here the S is what? That's 1 pixel in. That's what it should look like. And we've got it like this. So we've got 14 in. So we have to figure out why it's jumped. So the position, this should be 1, I think. 1 pixel in. Right. If I'm looking at this, not this, too many things open. I'm looking at this correctly. This, where's that 2 pixels? Oh no, on the very last line, that is 2 pixels, right. So this should be starting, actually, so let's go up 1 line earlier at 117. Oh no, that starts on 14 as well. Am I looking at this right? This, let's see, this, oh, 16. Oh, is there 2 pixels there? There's not 2 pixels there. Is there? Oh, I guess there is. There's like a drop shadow. It's hard to make out, but I think there's a drop shadow there. Maybe if we make this larger. Is that the drop shadow? It's gotta be. Because that otherwise doesn't really line up to, I don't think I have a way to zoom in easily here. But that would make sense if that's what's going on. Because it looks like there's a darker blue just below the lighter blue at the same level. You can kind of see it over here, I guess. But it looks like it's right. So that's, so position 118 is this dark blue, 117 is this light blue, and they're both 14 pixels in. And then 116 is 13 pixels in, and there should be 1 buffer, right? So that's that pixel there, but it really should be all the way over here, just 1 pixel in. So between these two, we're getting 12 pixels. All right. So where is that calculation coming from? First, probably determine. So, okay, so I'm printing it out twice. So if ADX printing it out twice, right? So it's before and after the increment. So it's got to be this. So there's some, so is HDX incorrect here? Let's just make this much more obvious. Let's do foo and bar. Just to be 100% clear. And then we will actually, I'll just print out more data. How's that? Let's do, so it says if HDX 1616, then times the pixel count. So let's do HDX. Come on. HDX 1616. 16. And HDX 16 equals and for the hell of it, let's just add HDY. So if maybe at the very beginning, this value is actually probably need pixel count too. So let's add pixel count equals D and do pixel count. All right, this hopefully gives us all the information we need. I mean, it won't tell us why it's happening, but it's a start. Okay. So let's go to level 116, where we've got pixel count of 13. Pixel count of 13. That doesn't seem right. The pixel count should be 1. Pixel count 13. So, right? So 13, then by HDX, that makes sense because that's going to be the width of stretching, right? So if this was 2, then it would be 2x. The vector would be a 2x multiplier on the x-axis. So this pixel count appears to be wrong because if we look at okay, pixel count, and then but then it says 3. I don't think that's right. Where's 1? Or maybe wait, maybe we need some more information here. Okay, let's try print f end of line, end of row, and pack literal, do printf literal, Oh, it's midnight. Ah, shit. I probably need to sign off. Well, let me do this one last thing, and then I'll sign off. So if we have literal, and we will want to, let's just do pixel count equals and then pixel count, and then do, oh right, so transparent and then printf repeat pixel count equals all right, this will give us, I think, all the details we want. I said that last time, didn't I? Too much shit going on. Oh, I didn't put, I gotta put this around everything to keep it from being too much. It's good enough. Okay. Right. So those are the end of rows I was saying at the beginning. So here we have, okay. Let's go to row 116. We've got end of row, right? Because the row before, or sorry, the end of here, and then we have an end of row. Okay, so then this 116 starts transparent 13. Wrong. That should be 1. And then from there, everything is probably fine, right? So we have literal pixel of 1, correct? That the tail of the S. Then a transparent for 3, right? That's the inside of the bottom of the S. That's 3 pixels. And then we got literal count of 2, which I guess is right. It's hard to tell. Yeah. So there's like a blue, dark blue right after the side of the thing. Right? So the rest of this is correct. So it's happening, this fuck up, whatever it is happening in the very beginning, in the very first transparency selection. So the pixel count is messed up. So where's the pixel count get set? All right, so let's start up here. Pixel count is defined within this context. Pixel count. So it gets set here. And that looks correct. Read 6 bits, add 1 to that value. And I guess let's do print pixel count equals pixel count. And let's see if that is fucked up. Like if it's read in fucked up. Because if it's read in fucked up, that might mean the parser is bad. And that's certainly possible, because I have found that when I was working on tooling, the 3IT tooling, the 3DO image tool that I wrote that will convert to and from 3DO cell images in a number of formats, I found that it's like very specific. Like there's like these very narrow edge cases that I kept running into. So let's go up to 116. And I'll be damned, it's 13. That's interesting. So I wonder if there's just something fucked up about the way that it's reading this. It's because it's coming in straight, like right here. It's getting 13 pixels of transparent data. And this image is only, what was it? Like 80 or, this image is 84 by, yeah, so it's certainly not that wide. And the positioning is at 0.16, so it's not even like the image is supposed to be wider, or is it? It's 72, but 12, so it's 13, and it should be 1, so that's 12. So maybe this is supposed to be offset by, is this supposed to be negative 12? Somehow? Because if it's negative 12 and this image is 84, but that would mean that, let's see where other things start. Pixel count 14. Let's just pick a random place where it, how about this? When it transitions. Pixel count 23. Maybe there's some sort of negative 12 that's supposed to be going on here. But I wonder where that would be coming from. All right, well, so I figured out some stuff. Clearly need to do more digging. I appreciate everyone who has been hanging out. If you're interested in 3DO shenanigans, I would recommend joining us on Discord. We have a bunch of homebrew people there and enthusiasts in general. I really need to make like a bot that allows me to just copy all this stuff into the chat, but consider joining us if you haven't already in Discord. And I don't know, I'll see if I can stream more of this debugging later in the week. If not, I'll just work on it if I have some time and see what else I can find. But clearly there's a missing 12 pixel offset that needs to be tracked down somewhere. And unfortunately, I can't just export this file and get a greater look at it, but it appears that, yeah, it's for some reason larger than it needs to be. And that this positioning of 0 by 16 is just not correct, or something should be affecting this. this offset. So anyway, thanks everyone. Have a good night or whatever. Good morning, and I'll see you next time.
The real 3DO interactive multiplayer from Panasonic, with the hottest CD games on Earth. Welcome to the real world.
Machusta.
Time Warner.
MCA.
Electronic Arts.
AT&T.
What have they heard?
Audio.
What have they seen?
Video.
What do they know?
3DO.
Interactive multimedia.
The new standard.
Breakthrough technology.
50 times the performance.
Custom graphics architecture.
Parallel animation engines.
32-bit RISC processor. You are in control.
There is no substitute for experience.
So fly into the future. Learn a new word.
Go in a jet or the wing of a bird.
See a whole new world or create one of your own.
Experience sounds never heard. Experience scenes never shown.
The 3DO experience.
If you feel your opponent's weight is forward and braced low,